So hi everyone, I'm Bart from Confio, and I will talk a bit about Cosmos smart contract basics, basically. There was the idea to do some live coding here, but I would go through because I don't have my laptop here, some technical issues, but it's fine. So there is a repository on my GitHub, HackATOM CW workshop. You can follow me there. I would show you how the basic system, based on two smart contracts, can be created. But first, let's talk a bit about the design. What the contracts are doing here. I figured out the idea for sharing donations, for example, between some some creators. Let's imagine we have a group of creators who want to increase their donators pool by, teaming up together. So if someone is donating one of those creators, donations are split according, depending on how much the creator is active, basically. So to achieve that, I created two smart contracts. And one contract is a peer contract, which is basically a single contract per creator. And the purpose is, there are two purposes of this contract. One is that there would be funds to withdraw by the creator who is attached to this peer. And also, if someone would like to donate on behalf of this creator, he uses this peer contract to donate. And how it works is when the peer is donated through, it increases internal counter, so he would get bigger rewards from other donations. And the other contract is the manager contract, which manages a couple peers or many peers. It is basically the pool of creators who are working together. And I am trying to keep this contract simple, so everyone can join to this peer pool. Everyone can leave at any moment, and you can also. There is also a donate function, but this donate function would not be called by some people who would like to donate the pool. It is only to be used by the peers. So when someone donates to this pool, he does it through the peer. Peer does its job, and then it forwards the call to manager. So this is roughly how contracts are structured. And we have a couple flows implemented. The join flow, very simple one. So creator is trying to join to the pool. I'm not sure if it's visible. Maybe enlarge it a bit. Okay. Okay, I cannot enlarge it. Anyway, so if creator wants to join to the pool, he calls join to the manager. Manager creates new peer for him and registers in internal map. And the idea is that manager needs all the peers registered for two reasons. One is to split donations after some distribution. And also, we need to keep information who already registered to the pool, so he doesn't register twice, for example. Leaving the pool is very simple. Creator just leaves the pool and peer is removed. And you can see that when joining to the pool, the peer is created, but it's never destroyed. We never destroy contracts, they are living there forever. But because the peer pool is removed from the map in the manager contract, it would be just useless because it would be impossible to donate through this peer or receive any donations. And here is the most interesting flow, which is donating. So how do we donate funds? Maybe let me read this. From the left there is donator, one peer, manager, and two other peers. So what happens? When we donate to the first peer, First, some funds are sent to manager. I say some because the contract is kind of smart, and if we donate on behalf of the particular peer, some funds are left directly on the peer, and rest are just splitted. Then the manager is querying for how many donators are on the particular peer, and it's done for every peer contract. So it's here, here, and here, and then every peer is responding with donators count. And after this donation count is basically retrieved from peer contracts, we send funds from the manager pool to particular peers. And you may see that there is not the best design because we are sending money for every peer, and basically we could send them directly probably to creators. That's true. The reason is to show how to communicate between contracts. That's the idea here. Okay, so this is the flow, and the last flow I have here implemented is I think pull withdrawal. So when we withdraw something from the peer, we need to be, the sender of the message has to be an owner of the peer, which he is assigned on creation, and then peer just queries its balance and gives back all the money to the creator. So very simple flow. And now I would like to talk a bit about how smart contracts are communicating, not looking at the code just yet. This is, I think, the most difficult thing to understand while creating smart contracts. I'm talking about IBC, which is kind of another story, but in terms of working with on single chain contracts, communication between them is kind of tricky. So there is this actor model, and the idea is that every message is processed by the contract from the beginning to the end, and the processing of the single message can never be interrupted. No other contract can be directly called. We can do queries for another contracts while working on, while executing some message, but we cannot actually execute other contract. And this brings problems because what if, for example, I need to, let's say this joining flow. What I need to do, I need to create the contract first, another contract, so I need to execute the instantiate execution. But I cannot store the address on the manager contract state unless the instantiation is finished. So I need to call instantiate while executing this join flow. So there is this notion of reply. So what does it mean is when we send some message to the blockchain from the contract, because every contract can basically schedule another messages to be processed after the execution is finished. So like here, for example, we have some free abstract contracts. We have blockchain here, which is the contract binary, I would say, just some magic thing which is executing the blockchain, and here is the message sender. So when we send to execute the message on the blockchain would send this message to the contract, because here I'm executing some message 1 on the contract 1. So message 1 is sent to contract 1. What happens now? Message 1 is processed from the beginning to the end, and it can schedule another executions. So here it's scheduled 3 executions, message 3 on contract 2, message 2 on contract 3, and message 4 on contract 3. And then what happens? They are executed one by one, never in parallel. They are executed one by one. And after, in the first case, I execute the message 2 on contract 2. When the message 2 is executed, fully processed, it just gives back information to the blockchain, that execution is done. And what happens next? Next message is processed. But while sending the message from the contract, contract one processing the first message, I can tell it to reply, send the reply message when the sub-message is processed, basically. And what does it mean? When the message, another message, message 3 is processed by contract 2, the message, after sending the response to the blockchain, that message is processed fully, blockchain sends the reply message to the first contract. And this reply message is where anything which is to be processed after the sub-message is finished happens. Yeah? I mean, I know it's kind of convoluted. You can look at the repo, it is like explained in detail, but there is this flow that I send this message 1, I scheduled message 3 to be executed on contract 2 here, I told to reply on success, and I provide the ID. And this ID would be sent back by the blockchain with the reply. That's very important because there's this thing that when we process the reply, we don't know the original message, we don't know anything about the state when the message was originally sent or when it was finished processing. We just have an ID, and we need to remember the state somewhere in the contract and then refer to it, sometimes via ID. And the flow can be very complicated in terms that we can send a sub-message from replies, we can send another message, sub-calls in, recursive way, but I will not, go in details through this diagram. You can take a look there. For now, I would like to go into the code, actually, because it's enough of theory, I would say. So let's take a look at the contract. Here, we have two contracts. We have donation peer and donation manager. Peer should be the easier one. It is. Okay, sorry. No, peer is the easier one. We can take a look first on HackATOM. So in smart contracts, there are a couple important things to put there. First of all, we need create type to be CDY library. And this is because our WAS smart contracts are the WAS dynamic libraries. They are not typical RAS binaries, they are dynamic libraries. It is also often that we add the error library create type, which is typical Rust library to be used as a dependency, for example. We often want to use contracts as dependencies, so we do that. Note that we create a feature, which is library, and I will tell about this in a second why I do that here. And I use a couple things here. The Cosmos stood, the standard library for Cosmos. Cosmos Storage Plus, which is the utility to access the Cosmos contract state. Std, which is kind of obvious, we want to serialize messages. And multitest, because I want to test our contract. So I want it to be there. And multitest is basically the utility to test contracts using the blockchain simulator environment. So go back to peer and go back into sources. And let's start maybe with messages we would have in this contract. And let's start with instantiate. While instantiating the peer, I would need owner of this contract. So this is the one who can withdraw money from it. And I added two additional configuration state. Incremental donation is minimal donation, which is needed to increment the internal counter, which is how much part of the donation someone would get on donations split. Yeah, so this is this minimal donation for that. And collective ratio is telling me how much of the donation is left on the peer itself and how much is forwarded to the collective, so to the other peers. And this is decimal because it's part of how much is sent to the manager contract basically. So this is what I do, what I take in instantiate message. On execute message, as I showed before, there are two actions. There is donate action. I do not take anything because I send funds with the message itself. I do not need to do this on the message. It's managed by blockchain. And then I have this withdraw function to withdraw money by the owner of the contract. And then I have a couple query messages. They are just, things I made to ask on the contract. I can ask the contract who is an owner, who is a manager. Manager is the pool who created him, the manager contract who created this peer. I can also check for how much donations are pending, which is basically querying for the state of this contract, and can ask for configuration and how many donations went through this peer. And this is important because I can use this donators query when I am splitting donations in manager. So manager could use this donators query to figure out what is, how much to give to this peer. And for every of those messages, I typically create the response structure to have some way to respond. Couple things to keep in mind when creating messages for Cosmos. We want them always to be serializable and deserializable by SERDA because those messages are just JSONs. We need to work with them. We typically also want debug, clone, and partial if we want to test on them, on those contracts, because, utilities thing. And we often add this SERDA rename all attribute. It is because without that, the messages would be serialized as they are here. So what does it mean? The owner structure, the owner message would be like starting with capital letter in the JSON. And we typically don't want to do that because it's more idiomatic in JSON to have it, lowercase. So because of that, we use this rename all to make sure by SERDA that everything is properly renamed to lower cases. Yeah, and another thing I need you to take attention to is this curly braces here, which are not needed by Rust at all. You can have empty enums not having any curly braces here, but it is for SERDA. Without those, the owner query here, for example, would be serialized to the string, just a string. On the other side, the spending donations, for example, because it's object with some structure, it would be serialized to an object with a single field called pending donations with the fields like denom here. To make this more unified, we use this curly braces, so it tells SERDA to serialize it as an object, not as a string. So this owner right now, because it has this curly braces, is serialized as another JSON object with single owner object. It would be an empty object, but with owner field name. Okay, so this is how we define messages in Cosmos. And then I would like to go, before I go to the contract implementation, I would like to go to the contract state. And what I have here, I decided to keep two distinct entries in the state. You can see that I have two items, one with some state structure, one with the address. I used those item utilities that are taken from CW Storage Plus library, and when I was starting with Cosmos smart contracts, I was kind of confused what are those items or maps for. So they are not storing any data. Any data in the blockchain are stored on the blockchain, not in the contract. And you will see that we get a particular depth argument to interact with blockchain state. The problem is that the blockchain is storing all the values like key value pairs, and there is no fancy things like serialization involved there. It's just, string to string mapping. Because of that, we introduced the CW Storage Plus crate, which provides the abstraction layer over the storage. So we use this, so we don't need to remember what exact string key we use to store the actual value. It also handles any serialization, deserialization, non-existing values for us. So this is just abstraction layer over the storage. And here we are using item, which means there is only single value of this type on the blockchain. What's interesting here, I splitted state to address and the state, and the reason is that whenever we use state, we most typically use the whole state. It's very rare that we want to use only donators or we need to use only collective ratio. We are using this while we are doing the donation flow, and we use all of that. So I decided to keep it in one variable. Another variable is the address, and that's a kind of a different story because I use address in completely different flow. I use the address, which is the owner address. I use this only on white Jowl flow to check if the sender of the message is the owner. There is an argument to extract the donators from here, and the reason is you will see later that I actually always read the whole state, but I would modify only the donators. So storing something on blockchain, reading something from blockchain is expensive, gas-wise. So I want to minimize how much data I am, sending to the blockchain. So to do that, I could actually extract the donators to another value. So when I am storing the updated donators, I do not need to store the whole state. I can store only the single data. But I decided not to do that in this case, probably for simplicity. And now it's time to go to the contract itself. I start with the lib rs, because here I have defined entry points. And I have, on this contract, it's kind of simple. I have 3 entry points, which is instantiate, execute, and query. And yeah, go one by one. Instantiate is the entry point which is called exactly once when the smart contract is created. So it's like construct of our smart contract, and its purpose is mostly to initialize the state. The other one, execute, is responsible to perform like standard execution messages. So as you can see, I keep those entry points very simple. For instantiate, I just forward to some instantiate function, you'll see this. For execute, I just do the dispatching on the message, but I never do any logic in my entry points. I want to keep them very, very simple. So as you can see, I just check if there is donate function, donate message sent. I just, I just call particular functions. Same for query. A very important thing that for queries, I return the binary type from the contract, but my functions would actually return the actual message types I created, not binaries. So I also use this query entry point to just call this to-binary function, which takes anything which is serializable and puts it to binary. And I would like to go through those entry points and take a closer look to the signature. So every function and any entry point would have this depth argument as the first one. And depth is basically the window to the outside world. Okay, maybe I can go. Sorry for that. Yeah, you can go to docs rs. Here I would quickly look for depth mute. So this depth type gives us the storage field, which allows us to work with the storage. As I said, storage is stored on blockchain, and this is the entry point to modify it to read the state of the current contract. I have also this API thing, which is providing us some helpful functions, for example, validation of the given address and so on. And query is the object which helps us querying data from the outer contracts. We use it either to call the contract queries or to just look into the contract state. For example, we can read directly from contracts. We'll see that in the example. We can also query another things like, for example, bank. We can query for how many tokens is available from the contract, and I think I use it also here. So this is depth. You can see that for query, there is no depth mute, it's depth. And what is the difference? The difference is that if we take the depth type, we cannot modify the contract state. And queries never can modify the contract state. It is only for querying, it's like completely constant. Both execute and the instantiate can actually affect what is stored on blockchain by its nature. Another thing is environment. I do not use it in instantiate, I would use it in execute. And environment is a type containing some information about the blockchain state. It tells you what is the current time in the blockchain, how height is the blockchain, how many blocks are there, and also what is your current contract address. So you can directly relate to your address, you don't need to send it every time. Also there is this info type, which is passed to some of entry points, and this is like meta information object containing some special data sent with the message itself. You would have the message sender, where you never send the sender in the message itself. It is validated by blockchain, and you can always be sure that whatever is in info sender, it is the true sender of the message. There are the funds, the native tokens sent with the contract, so you also know that the contracts, that the funds sent are the actually sent. It's everything validated by blockchain. And the last argument would always be the message itself. Almost always reply is a bit different, but I would tell about reply in a second in a different contract. So as you can see, execute and query entry points are pretty much similar, except that a query cannot depend on the message meta information. There is no message info on the query entry point, and it is because funds cannot be sent there, and query result is public and should not depend on who sent the message. Basically, those information are completely not needed on query. And yeah, another thing is the result of the functions. So most entry points, and I think that all entry points except queries would return the response type. And the response type is the type which is very closely related to this actor model. We put there every message which should be executed after the execution is completed. We put there any information which should be returned to another contract and so on. So this response type is just like actor model handle, basically. And I said that all entry points besides query return that. Query just returns the binary information it returns, because the query is not, the query entry point is not working as an actor in the actor model. We can, query contract just while working on some other execution. And one thing you should also take close attention to is this entry point attribute. Why do you have it? Basically, Cosmos smart contracts are compiled to WASM. But WASM itself is not working with like complicated Rust types. We cannot send depth mute from the WASM ecosystem directly. We can only send pointers, some integers, and things like that. So to work around that thing, we just create like high-level entry points, like instantiate, taking all those fancy attributes. But entry point decorator, I would say, attribute is a procedural macro which generates the actual entry point for you. The actual meaning the one which would be able to be called from the WASM ecosystem, using only those pointers and stuff, and the entry point would wrap all those stuff in the nice Rusty API, and then it would basically call the instantiator or the entry point. So now let's go briefly to the contract itself. Instantiate, very simple, and I am showing it on here only to show you how to create instantiate things, what to think about. First of all, I always want all my state to be instantiated, initialized. So this is what I do in instantiate, I initialize the state. And this is basically all. I don't do anything else. More interesting is the execution function, and I create a separate module for execution functions. And let's start with the withdraw execution. How do I implement that? It is the simple flow, so I need to load the owner on the contract from the storage, because contract knows who is its owner. I instantiated it on instantiation. And then I just check if the owner is the same thing the same address who sent the message. If it's not, I just return an error, because I can't handle one withdraw if there is nothing to withdraw. I mean, there is wrong owner. Also, when everything is okay, then I need to query for all my tokens for this contract, and I would use this environment variable here, where I just check the contract address, my self address, and I ask the bank module with this query, how much tokens do I have? Right? So those are my donations, which are collected since the previous withdrawal. And what I do next, I add message to the response to be executed after the execution is completed. And the message is the bank message, so the sent tokens sent order. When I want to transfer tokens from my contract, which is always the source for the sent message, to whoever is the sender of this message. We already verified that sender is the same as the owner, and I need to tell what tokens I want to send. I want to send all my donations, so my amount is my donations. Also, what is nice things to do is always add those attributes, and attributes are basically logs from executions. I don't like to use them to transfer data. Sometimes we do that, but it's way better to use data for that, the proper field. But I treat attributes just as logs, and the sender of the original message would collect all the attributes set by every sub-execution, and he can basically trace what happened on the blockchain. And this bank message would be executed right after this execution is completed. The withdraw execution is completed to transfer all the tokens. And now let's go to this a bit more complicated donate thing. What I do here, first I load the state, because this is something I store my counter in. I store all my metadata I need to work with. And then I need to check if I want to increment the internal counter, because I increment it only if funds sent with the message is basically more than the by this incremental donation in the state. So I just go through all the funds sent here, and I check if any entry in that funds is of a proper denominator and has enough amount. The funds is just a vector of coins, and coin is denominator and amounts of those coins. And it's guaranteed by the blockchain that every denominator is only once in this map, so we can just going through that. It is the useful crate called not here. Go to docs.rs. CW utils, which has couple helpers to work with funds. For example, non-payable, some must pay and may pay functions. You can go through this because it makes working with funds easier. Here I just iterated to check if there is proper donation of the denom I expect here. And if I want to increment the state, I increment the state and store the state. If I do not increment it, there is no reason to store the state, so I minimize the data transfer there. And then what I need to do is I need to split the donation into two parts. One is the part which I leave on the contract, and I don't need to even store this, but I need to calculate the part I want to send to this manager contract to be split between users. So what I do, I just iterate through all the funds I got there, so all the tokens I got sent, and I just map them. So I just multiply the amount of the tokens sent through collective ratio, and this is how I keep how much donations I send to the manager, and I simply just create the execute message. So it's sent to, so the manager contract is executed. So the execute message is just like a bank message, but instead of scheduling sending funds to the contract, it schedules execution. So I schedule execution of the donate message. So it's here. I need to call to binary because the message is basically base 64 encoded message. And then I need to set the address I send to. I send it to my manager from the state. And also I can send some funds. I send my collective donation funds, which are sent here. And again, I send the message. It will be executed right after the execution is finished and because I use this at message as before, I would not get any reply here. On this pure contract, I never got a reply. I never handled the reply. So this is the simple contract. Now let's quickly go to this more complicated, a bit more complicated manager contract. So here, messages are pretty much the same thing. So I have some instantiate message. Very important thing that on instantiate message, I need to pass the peer code ID. And what is that even? So when we create our smart contract, we compile it to WASM binary. Then we upload the binary, the WASM file to the blockchain. And it is not a contract yet. It is just, the reference code which handles the execution, instantiate, and so on. And the contract is created only after the instantiate message is called. So when we instantiate message, we need to send the code ID and the instantiate message. And yeah, with that, the contract is created. And because our manager contract would create other contracts, we need this peer code ID, so we know what to instantiate basically. And also we give this incremental donation and collective ratio just to forward it to the contract basically. Execute message, nothing fancy here. Query, nothing fancy here. So let's go back. State. And in state, there are three things. First, config, and this is very simple thing. The same thing we had in the peer contract. I would not talk about this thing. But there's members, and members here is a map. And it should not be a map, but I try to simplify things. As I told you before, blockchain is just a key value pair, key value storage. Yeah? And if we would want to store like multiple values which are connected, what we would need to do, we would need to prepare like distinct key for every entry. I keep it map. I mean, and this is exactly what this map does. When you would use the map to store something on contract or read something from contract, it will use this this members string we created with, and it would concatenate the string with the key we are storing on the map. So it does all this keys handling for us, and also authorization and things. What I map here is the peer contract address to its owner address, and I would not need to do that, but I want also the contract at the original owner address, the creator address here, because I don't want to allow any creator to add himself twice in the join flow. So that's why I keep it here. But it creates the problem because to determine if the address is in the map, if it's in the value, I would need to iterate through all items, and it is not the fastest things to do. I do it here, but I could not to do that if I would use another accessor. Let's go to documentation. There is this multi-index map. So multi-index map is just like a map, but it allows you to access your data in the map using different indices. So it is what we want here. We would like to use either the peer address or the creator address to access the map. But using it is not so easy. I didn't want to go into that here, but it's worth knowing that there is this thing which is multi-index map to address like this. Here I just used map from peer to address. There is the question why I didn't map it the other way, so the creator address to the peer address. This is because I decided that splitting donations is way more common thing to do, and in this case I prefer my peer addresses to be keys, but this is not optimized at all. To optimize it, I would use multi-map. And there is another thing which is interesting, is the pending instantiation. And this is the thing. I told you that when I break the execution to schedule some sub-message call, then I cannot like start from some place. I cannot like break execution, then do some subcall and then go back to execution. Yeah. After the subcall is finished, I just got another reply message, and I need to handle it from the scratch. But here in the map, I need two addresses to store when the instantiation is finished. I need the peer address, and peer address would be given to me back with this reply message. But I also need the creator address to store it here. And I would store this creator address temporarily in the contract state. So when the replay is called, I would be able to retrieve it. And let's go to library rs, because there is one interesting thing, which is the reply function. So yeah, we have all those instantiate, execute, and query entry points as before, but we have this another special reply entry point, which is called when the submessage we scheduled is finished, but only if we register the message to trigger the reply. So what I have here, I have this depth mode and environment. As you can see, I have no message info here. And this is because on replies, we basically lose the information about the initial message we got. Reply has no additional context. It has just the reply. And reply contains two things. One is the ID, and this is the ID we sent to the original message, so we can correlate the message we sent with the reply. And the other thing we get is this message result, which is basically execution result. It's very important that this result may be a failure. So it is possible that if we send some sub-message, but we registered on the reply, even if the original message failed, we can still capture the reply, and we can tell that, okay, the sub-message failed, but I want it to be considered be successful. Yeah? It is very important because the nature of the smart contract executions is transactional. So for example, if I sent the bank message previously in this peer contract, if, for example, there are not enough funds on the contract I'm sending from, which is not the case in this situation because I just queried for that, but it may be that the bank message fails, then no state is changed. I mean, even in a state which we change in the execution message, the original message, are not applied to the blockchain state. So what happens is that when we execute the message, we create like temporary cache, and every changes are applied to the cache. And the cache is applied to the blockchain only after all sub-messages are processed and all sub-messages succeed. But if we want to allow sub-message to fail and still apply the changes to blockchain, then we can just catch the failure replay, and we can work on that. So let's see how do I implement it, some messages. Instantiate is trivial like before, but there is this join flow. And this is actually not so trivial. I think it's the most complicated thing here. So how do I implement the join to the pool? First thing, I need the sender of the message because I need to tell the newly created peer contract who is its owner. The owner is whoever is just joining, right? Then I need my config to be loaded because I also forward my whole config to the newly created contract. And then I create the was message instantiate function. It is very similar to the execution message, except I have another couple different fields. I have this admin field, which is basically the address who can migrate this contract. It's very important that admin here is only for migrations. And in this case, I do not even consider any migration flow, and because of that, I do not start admin. So this admin here, I mean, there's often a case where there is a notion of an admin in the contract which is managed by the contract itself, but this admin on instantiate was message instantiate is not related to whatever is in the contract. This is only the admin who can migrate the contract. Yeah, I obviously send the peer to the peer code ID, which I want to instantiate. I add the message itself. I can send some funds, and so on. But why I said this is complicated flow? There are two things happening here. First of all, I need to store the sender in my pending instantiation. I said it before, I would need to do that, and the reason is I just want to finish the flow. I want to finish the message handling and send the instantiate. But what I do, instead of sending message, I send sub-message with reply on success. So I tell the blockchain that when this instantiate is finished, call reply on me. and I send the message, I give the message I want to send, and I need to give an ID. Here I set it to the constant. Constant is just one here. And this constant is something I would get back when I would get the reply call, right? So it can be kind of strange because I always send this instantiate with the same ID. So how do I know that my message I just received is the same instantiate I sent for the last time? And this is because there is this rule in this Cosmos that the message is processed like from the beginning to the end. And since I started this message, this join handling, nothing can happen on this blockchain, on this contract state, unless our sub-messages are completely done. So if I send just a single message, then I know that the next reply I get is this reply to my instantiate. I can get no message back because on failure I would get no reply. On failure it would just break the transaction, nothing would be stored on blockchain, and nothing would happen. But in such case, this pending instantiation would not even be stored, actually. Yeah, I also set some log attributes, but that's not such an important thing. And as you can see here, on this sub-message, I set this peer instantiate ID on the contract. And if we go back to the library, on the reply entry point, I dispatch on this ID, and I use it basically as a message type. So if I see that the ID is peer instantiate ID, then I know this is the response for this peer instantiation reply. And I would use this handler here. Sometimes I would have more than one message I want to handle, and then I can dispatch it here using ID just like message type. And this is kind of common pattern to use. So go back to contract here. Okay, so join is finished. Sub-message is sent. Sub-message is executed by the peer contract, as we've seen before. And the replay is sent. Replay is dispatched to this peer instantiate. And you can think about this join as a single execution. That's why I keep them kind of together. And the first thing I do when I am handling the response here is I am checking the result. And it is kind of redundant here. It is redundant because I specifically set that I want to reply only on success. So I could technically unwrap this. I just do not like unwrap on contract, so I handled this error here in case, for example, I would like to change it in the future, so I want to, I don't know, I want to reply always, for example. Then I have this still working, and I would not produce any crash on the contract, and crashing on contract is not a good thing. Yeah, and when my result is handled, then I get this data, and the data is the field on response. We can even set data on this response type. There is, I think, add data or set data function to set this. This is arbitrary base64 encoded data. So it can be, for example, serialized JSON. In case of instantiate, it is a protobuf object. But I don't want to work with protobuf here. Hopefully, I don't have to. First thing, I check if there's any data, because it is an option, it can be empty. But then I use this parse instantiate response data, and this is the function from Cosmos utils. I showed you this crate before. So Cosmos util is a very useful crate which gives you things like, for example, this helpful utilities to parse this instantiate protobuf object. So I parse it, I check errors. I mean, not the best way to handle them, but some way. And then what I do, I just need to retrieve this pending instantiation I stored before. So as you can see, I cannot like keep data in any kind of memory, but I can store them between execution and reply, and then I just retrieve them. And this is common pattern to do. And then I save entry on my members. So this is how we often handle like multi-stage executions. We just create initial part as an execution message, and then we follow this up with reply. Obviously, in reply we could have another calls. Another sub-messages scheduled. It would be okay to do that. And then we would have another reply on those sub-messages. We would typically differentiate them using some message ID. Sometimes, if we send couple instances of similar messages, we can do some we can store some ID on this message ID, and we then just bitmask it. So part of it is the type of the message on the ID, and part of it is actually identifier of the message we sent. Yeah, so this is how we work with reply. Leave, nothing special here. We just check. We just look for address to remove and remove it. But donate. So also kind of tricky flow. And the donate flow doesn't start here. As you've seen before, we created this donate function on peer, and there was this add message on response, which was calling this donate. This is what happens when external peer called donate on us. First of all, I don't do it here for some reason, but I could check if the message is sent by a proper peer. So I could look for the sender, look in this members map. I would check if there is a key for it, basically. What I do here, I go through all the members, and I query the external contract. And I could do that two ways. First, I could use a query object from this depth thing. I could use this query object to call this donators query, like use the smart query. And I actually think I did this in the previous version, just to show it. Let's go here. If we go to the contract here, yeah, not here. Yeah, yeah. Initially, I used on the previous version. I used this query object to query wasm smart to the external contract, to the peer contract. What is the problem with that? When I do this smart query, I first need to serialize my query message. Then I need to deserialize it again on another contract. It is basically expensive, gas-wise. And because of that, we can use this this, it's in donate, yeah. We can use this query function on the item from another contract. The state here is the object, if you can go to the imports. State is the object imported from the donation peer, from another contract. And I can use this CW storage plus state object or item object to read from it from external contract. What it does under the hood, it uses the query. We need to even pass it, I think. We need to pass the query, and it uses a thing called raw queries, which is querying the contract state directly. And this is way cheaper gas-wise because it is just serializing or deserializing data we need to deserialize. We do not need to create any, intermediate messages to do that. So this is something we like to use. The problem with that is that the contract state is not exactly the contract API. The contract API is defined by its messages and, for example, by the query messages. So here I assume that the contract I am using is I assume I know how the state is structured. I assume there is this state in the contract. If someone would, for example, use the other contract here, it may not work. But because my manager contract is responsible for creating those peers, it is basically safe because instantiate contract knows exactly what contract it is creating, knows exactly what version contract is creating, and it is connected somehow, one to each other. So this way I just ask how many donators are per contract. I can add them up to calculate totals, and this is repetitive work. I just query for how many funds are on the manager, and why I use this query all balances instead of just relying on funds sent to the donation. It is because when I am distributing funds through my peers, it may happen that division would not be exact. There would be some left over. So to handle that, if there is any left over, I would just redistribute it in the next call, because I would always use the whole balance stored on the contract instead of just funds which are directly sent. One kind of important thing is that I want to not send, I don't want to send empty messages with no tokens to be sent. For example, if one of the peers has zero weight, it may happen at the very beginning. It is because sending 0 tokens would fail. So to not send message which fails, we just do not send it. Because if the message I sent would fail, the whole transaction would fail and nothing would happen on blockchain. Another way of handling it would be to, instead of send messages, I could send sub-messages with reply on error, and if there is an error, I could just accept it as it is. That's another way of handling it, but here I can just prevent the sending message I know which would fail. And this is how I implement contracts, basically how to have communication between contracts. There is another thing I would like to tell you quickly, which is how to test contracts. There are two ways you can imagine. One is to just create unit tests, to unit test those functions like donate. Yeah, I can call donate with some fake environment and check what happens. There is a problem that it doesn't allow for easy testing the relations between contracts. Yeah, it is testing only single function call. It is okay, but it is not enough in most cases. Another way is we could just test it on the testnet. Yeah, we could create the fake testnet, we could send some messages, and we can check what is the blockchain state. The problem is it's not so easy to set up and automate. So what we created is this crate. We call it multitest. We can find documentation like here. And I really recommend to check the multitest crate. If you want to debug your contracts, because there's the problem, debugging contracts or blockchain, I don't think it's even possible. I don't know the way to test contract directly on blockchain or debug it. But what we can debug are unit tests. First of all, we can just print inside of them. And the other thing, we can actually run the LLDB on the test binary, because test binary is our native library. We can easily test it. So what I do here in donation manager and also in peer contract, there is the example of not in contract, sorry, in librs of multitest tests. So how does it work? First, we need our contract wrappers for our contracts, which are objects for multitest, so it knows how to execute contracts. It is basically equivalent of the WASM binary, but for multitest. And if you look at the test, it is kind of straightly manipulating the fake blockchain environment. We create the app object, and the app object is the object being a blockchain simulator. We just store code. So this is just like, sending the code to the blockchain via WASM-D or something. Then we just call instantiate contract. So we do calls on blockchain here, straightly. I send some manager code ID. I send the second is probably sender of the message. Then we send the message itself. I send some funds and so on. I can just query the blockchain. So I do not query the particular contract. I query the blockchain. Query was smart with the address. Here is the manager address which I have from the instantiation. And I send the message. And here there is anything which is JSON's erasable. I could even use the JSON object from third JSON, I think. I mean, it may bring some problems, but basically anything serializable to JSON can be here. And then I just assert on if the config response is what I wanted to have. Yeah. Same for members list. Initially, I don't want any members on the list. And on the join, for example, test, what I do, I just instantiate the contract. Then, is it the join flow? Oh, sorry. It is. I instantiate the contract on the join flow. I execute join by the member. Then I query the peer address, and I check if the peer contract is properly initialized. So I check if member is an owner. I check if manager is the manager. I check if donators are empty, are zero. Yeah. So basically, I can use the Rust unit test environment to create my smart contracts easily. And even donate flow. Here I left some comment that there is a single donation. As you can see, I just call execute contract donate here. I just donate by donator with 100 of T grades here. And then my member is trying to withdraw money from it. If it succeeds, then I can verify balances on donator, on peer address, on everyone. And this is just like creating unit tests, but with the blockchain stub or simulator, or however you call it. A very important thing is that I mean, this is something we would probably like to work on a bit, but the API to set the funds on the initial funds on blockchain is kind of tricky because we need it to do it while instantiating the blockchain. So we pass this lambda or this closure to application new function. And what we need to do is to call this init balance on everyone. We need to give them some tokens, and because donator needs some tokens to donate, we give him some tokens. Yeah, there are more examples, like more complicated donate flows, but they're basically the same thing. So I just instantiate contracts, I send some execute messages, then I query the blockchain. This is how I test. One thing with multitest I would like to show you is in the peer contract. So when I test peer contract, before I said that I need to instantiate the funds while I initialize the blockchain. So I do it in app new. But it is not always what we need, because when I try to test the white draw on the peer contract, I would like to do it in very pure way. So instead of creating the whole donation flow, I would like just to set some initial funds on the peer contract. But I cannot do that while I am initializing the blockchain. And the reason is because I don't have the contract yet. It's not yet instantiated, it's not even loaded. So what I do, I create the contract itself, I store the code, I normally instantiate the contract, but then I call up init modules. And init modules is like delayed initialization of modules here. And I just init bank balance here. Yeah, and it is everything I have here. I am, I think, below the time, but it's okay. Sorry for this format, but I had some technical issues. Didn't have my machine, so I couldn't show you this whole thing while coding. Maybe it would be more easy to understand, or maybe not. But yeah, this is everything. If anyone have any questions about that, I can answer it. I can also help you with anything regarding Rust or smart contracts or multitest. Just while HackATOM, just find me, ask me. I am Cosmos maintainer. Also, we are running the Academy thing, so everything here would be taught on Academy. This contract is basically what we are creating on the Academy, step by step, in a slower way. Here I just made quick review of this contract. Yeah, so thank you for attendance, and if there are questions, I can answer. Yeah, otherwise it's all. So thank you, bye.
All right. Can everyone hear me okay? If you can hear me, clap once. If you can hear me, clap twice. All right, thank you. So I'm Nick. I'm on the Evmos team, and I'm here today to talk to you about how Evmos brings Ethereum smart contracts to the Cosmos ecosystem. So for those of you who don't know, a little bit about Evmos. Evmos stands for, it's a portmanteau of EVM plus Cosmos, and it basically combines the best of both worlds. It brings programmability and composability from the EVM to the Cosmos ecosystem, which is known for its sovereignty and interoperability. And the way things are implemented on the low level is that Cosmos SDK lets you build modules that you can compose together to build your own L1. And the EVM here is built in the form of a module, in the form of a Cosmos SDK module, which lets L1 builders extend their chain, whatever chain that may be, by adding an EVM to it. So that lets developers deploy any Ethereum dApps that work on other EVM chains to a Cosmos SDK chain, right? But the current Evmos team in 2022 is by no means the first team that sort of thought up this idea. A little bit of a history lesson here. Ethermint has been a long-running idea in the Cosmos community. Ethermint, of course, being portmanteau of Ethereum and Tendermint. Ethermint was initially proposed as a Cosmos zone that would combine native Cosmos functionality with Ethereum smart contracts. And this was proposed way back in like 2016-17. And on the right, you can actually see a talk that Chris Goes gave back in 2018 on Ethermint 2.0, right? Which again is Cosmos plus EVM. So we were talking about Ethermint 2.0, not even the first version, all the way back in 2018. Several teams in the past have tried to launch this Ethermint idea as its own chain, and it's only this year that the Evmos team was able to launch the Ethermint idea as Evmos. And I'll talk a little bit about how the Ethermint idea evolved into Evmos. But sort of the core thing that attracted so many previous teams to build out the Ethermint idea was the fact that you could offer developers the same Ethereum environment that they were used to. So, you know, working with things like MetaMask, Truffle.js, Hardhat, Foundry, Remix, all the tools that they knew and loved, but with features from the Cosmos world like proof of stake, Tendermint fast finality, and Cosmos's on-chain governance, which is super underrated at this point in time, right? Oh, I just realized it's not full screen. How do we make it full screen? Oh, there you go. That's a bit better. So I was talking about how attractive the idea of Ethermint is, and it's not just an attraction from the Cosmos side. It's not just folks like Chris Goes who've been in the Cosmos community for a long time who've been talking about Ethermint, but folks from the Ethereum side as well have also sort of sought after this idea of a fast finality chain for Ethereum. So you can see here tweets by Vitalik Buterin and Martin Kopelman, and even our very own Sunny from Osmosis, talking about a future where Ethereum leverages fast finality, fast single slot finality, and there have been other materials, talking about how Ethereum wants to implement the merge and bring proof of stake to Ethereum. So really, the Ethereum folks are talking about how they want to be a Cosmos chain without really saying that part out loud, right? Cosmos chains, of course, deriving a lot of their properties from the consensus engine Tendermint that they use. So that's where single slot fast finality comes from, right? So we talked about Ethermint. So when did Ethermint become Evmos? Right. Last year. When we were building out the Ethermint idea after it had been abandoned by the last team, we realized that the EVM space had come a long way since the Ethermint idea was first proposed. Back when Ethermint was first proposed, there was just a single EVM, Ethereum. Since then, other chains like Polygon, Optimism, Avalanche have all launched and sort of use their own unique stacks to a large degree, right? And so we realized that the vanilla Ethermint approach didn't actually add that much value on top of the EVM chains that were already out there. So what we decided to do is to build Ethermint into a library module that anyone out there could use for their own L1. What this means is if you're an L1 builder building with the Cosmos SDK and would like to enable Ethereum smart contracts for your chain, you can just plug and chug the EVM module in the form of Ethermint into your L1, right? Giving your L1 an EVM runtime out of the box, right? So Evmos comes as a flagship representation, basically a proof of concept for the Ethermint library, and both are open source. And we've seen the community actually fork both in recent months, which further demonstrates the validity of the core thesis that we had initially, that Ethermint would be most useful as an open source tool for others to incorporate into their L1s. And you've heard of many of these chains. There are chains like Kronos, Kava, OKX chain, Kanto, and these are all chains that use Ethermint. So Kava's EVM cochain runs on Ethermint. Kanto is a fork of Evmos with a few of the Evmos specific modules torn out. Kronos implements an early version of Ethermint. And you know, was able to launch actually before Evmos even went live, because we were working on Ethermint at the time, and they contributed to the repo. What's also interesting about Evmos is that it takes a community-driven approach. So Evmos got its start in early 2021 when my co-founder, Federico, wrote up proposal number 44 to the Cosmos Hub. So proposal number 44 requested a grant of 100K Atom in order to build out Ethermint. And it was still called Ethermint at the time when Federico made this initial proposal. The community knew that Ethermint was an idea that had been long coveted by the Cosmos community, and so they voted to fund this proposal. And it's, to this day, I think Evmos is one of the few L1s that was funded entirely by a community. So, you know, no private interests, no VCs, just the community launching a chain. You know, other examples of this since then have been chains like Juno, and I think Neutron is the latest exciting chain that will be coming to the Cosmos. I think it's Neutron. As a result of this community-driven approach, we, the Evmos team, decided to grant the community 60% of the initial token allocation, with 40% going into the strategic reserve for Evmos to ensure its continuity and longevity. Right. The spirit of the community-driven approach that was kicked off back in early 2021 has continued long into Evmos' lifespan, with things like major events, projects, and incentives being entirely planned by and funded by the Evmos community without necessarily the involvement of the core team, which allows the core team to focus on the engineering side when dedicated community members can push other initiatives forward, right? Which is very, I think, in the spirit of what the Cosmos ecosystem is all about. A huge example is this very event was sponsored by the Evmos community pool. The core team had very little to do with that decision. The Evmos, besides, in fact, just being here and talking on this stage. So yeah, props and shout outs to the Evmos community. Now, a little bit about what Evmos tries to do as an extension of the original Ethermint idea, right? When we were building on Cosmos in the early days, again, my co-founder Federico was one of the folks who worked on the core IBC repo as well as the Cosmos SDK repo early on. We realized that Cosmos was facing somewhat of an existential issue, and this is back in 2021, remember. Electric Capital put out a report, maybe you've seen the chart in the top right, of the number of developers who are building in Cosmos compared to other ecosystems like Bitcoin, Ethereum, Solana, etc. Right? The number of EVM developers out there far outnumbered the number of Cosmos developers by an order of magnitude. Now keep in mind, this report isn't entirely perfect. It only, leverages data from repos that are open source. And so I'm sure there are closed source repos out there where there are, Cosmos developers are building in private. However, the point still stands that there are way more EVM developers out there than both Cosmos SDK developers and CosmWasm developers as well. And that makes sense, right? Building L1s is way harder than building dApps. You have the additional friction of having to bootstrap a validator set from scratch as well. So the idea here was to bring the EVM to the Cosmos so that EVM developers could just leverage, as I mentioned earlier, could just leverage all of the tools they were familiar with in order to accelerate development on Cosmos. And I'll talk a little bit about what the trajectory might look like for developers who start off building a dApp on top of Evmos, who will later then evolve that dApp idea into its own chain. Recently, DYDX launched their own Cosmos chain in sort of a similar trajectory as what I'll describe. And so that's a very exciting sort of validating case study for this thesis. Right. So in summary, if we were to summarize the idea of Evmos and why we chose to launch it in the first place, beyond just making Ethermint as a library, as a module, just open source, was that we see Evmos as the point of entry for liquidity and developer mindshare into the Cosmos ecosystem. Right? As we mentioned, Evmos is built by the community, driven by the community, but built for developers. The fact of the matter is that Evmos moves incredibly fast at a breakneck pace. It's only been live for about 2 to 3 months at this point, and we're already on version 6 of the Evmos software. And we'll be launching version 7 fairly soon. This means that developers can make requests to the core team as far as the features they want to see, the things that would help out their development the most, and the core team can work towards incorporating those features in a turnaround time of months as opposed to years. Again, I keep mentioning that all of the tools that work with Ethereum and other EVM chains will generally work with Evmos out of the box with very little additional that's needed on the developer side. So things like explorers, wallets like MetaMask, UIs, dApps can be ported over to Evmos, again, with very little changes to the code. The last piece here is that Evmos enables certain features that no other EVM allows their developers to leverage. So I'm talking about interchain dApps. dApps that can talk to other chains directly without the need of a bespoke bridge. Right? And this is not just for token transfers, but also arbitrary function calls. All right. There's this idea brewing amongst the Evmos core team of a dApp store. And I'll talk a little bit about the dApp store idea more when I'm talking about incentive misalignment. But essentially, the future of Evmos is one that's incredibly consumer-facing with discoverability, searchability, and general legibility tooling for developers to bring attention to their dApp to new audiences, from new audiences. And again, I'll be talking about what the dApp store experience actually is. So we also mentioned that Evmos is a port city for liquidity as well. As a developer, what you're able to do when building on Evmos is gain access to two ecosystems. One is obviously Ethereum and all of the liquidity and tokens available through Ethereum. And Evmos, again, can be bridged both to Ethereum and to the Cosmos ecosystem over IBC. And so what you essentially are able to do is get access to tokens on both sides of the ecosystem. And not just that, for every new chain that launches in the Cosmos ecosystem, Evmos developers gain access to those audiences as well, again, over IBC. And this comes for free with no additional work that's required on the part of any of the dApp developers building on top of Evmos. ERC20s from Ethereum can work seamlessly with Cosmos chains. And likewise, Cosmos chains can be transferred over to Ethereum through Evmos seamlessly again, over bridges like Nomad and Connext. And again, the interoperability piece allows users to manipulate balances on other Cosmos chains directly from Evmos. That small idea lets developers build out sort of a new axis for UIs, what we call next generation UX. One example of how Evmos accomplishes this is allowing users to use MetaMask to not have to switch the tooling they're used to. So Evmos caters to audiences both in the Cosmos and Ethereum communities, and support for things like voting on on-chain governance, staking on Cosmos through this Cosmos staking module, are both supported over MetaMask, which, as far as I'm aware, is one of the few times where MetaMask can sign payloads for the Cosmos ecosystem directly, right? On the flip side, we're working with the Kepler team to have Kepler, which is, as you know, one of the biggest Cosmos-focused wallets. We're working with the Kepler team to enable EVM signing through Kepler, which means that, again, once both wallets, MetaMask and Kepler, and all of the Wallet Connect wallets as well, once all those have parity, it shouldn't matter what users are used to using, anything will work on Evmos. Let's talk about one of the challenges that Ethereum developers face when building for a multi-chain environment. When building for a multi-chain environment, so taking the example of Aave here, when building for a multi-chain environment, Aave is able to deploy their smart contracts on multiple EVM chains, right, without needing to change much about them. And this is sort of what's done usually. New Aave deployments are approved by Aave governance and are deployed to whatever new chain is out there. And so that's where TVL will coalesce, as well as the user base there. However, if we're shooting for a future that surpasses the Web 2 experience, we really need to start thinking not on the L1 level, but on the dApp level. It shouldn't matter to the end user what infrastructure their dApp lives on. It's not as if in today's world the user has to think about whether the app they're using is built on top of AWS or Google Cloud. In a similar vein, we want to make sure that the user isn't thinking about what L1 the dApp they're using is built on top of, right? On the developer side, the pain point comes in the form of the fact that every dApp needs to track every deployment that they make. They need to manage those and upgrade them individually. If there's a bug in one contract that's found, every contract needs to go through an upgrade process, which is tedious and cumbersome. What Evmos enables is, instead of a multi-chain deployment strategy, we like to opt for an interchain deployment strategy, where single deployment is sufficient and enabled to talk to other chains. So if Aave wanted to, they could deploy on Evmos, and through Evmos, have their users talk to and manipulate their balances, assets, tokens, etc. on other chains. Right? We see this approach as much more scalable in general. Again, this is what we call interchain composability. Deploy once, connect everywhere. Again, focusing, circling back to the user pain points, interchain accounts, which is a feature in the Cosmos ecosystem, means that users will no longer need to switch between networks, right? Again, trying to enable that vision of having the user not need to care about what chain they're using, only what app they're interfacing with at that moment in time, right? The interchain accounts experience enables transactions to be fired from a single chain with a single user address. The user will never need to switch between networks because, again, they shouldn't have to. We haven't seen this much yet, but once interchain accounts is adopted more broadly in the Cosmos ecosystem, we'll see massive shifts in how UI is built and thought about amongst developers, as well as a paradigm shift in user behavior, demanding not to have to switch networks every time they need to manipulate a balance on a different chain, right? Ideally, again, they should only have to use one address, one private key, right, to sign for any balance on any other chain out there, right? And Evmos is just a small part of that puzzle, but we're trying to make interchain accounts, you know, the paradigm shift of the future. So I mentioned the dApp store, and part of the idea that seeded the dApp store was the fact that we saw a misalignment in incentives for those stakeholders both building and using blockchain networks. So, as we all know, EVM chains, much like any chains out there, are formed by multiple stakeholders, multiple community members, and different demographics, different user segments, right? Examples of this are folks like miners who have very different needs and incentives to run chain software than users do, or than developers do, right? However, only miners were really incentivized in the past to bring value to the ecosystem. So for all of their work, developers and users have been traditionally left out of this value accrual mechanism. So we asked the question, how can we align dApp devs and end users as well as miners who reap rewards from things like transaction fees and block rewards, all right? And yeah, so if you read our token model blog post that we put out, what was it, I think in December of last year, you'll see that there's a strong focus on the three key stakeholders that I've mentioned so far: validators, developers, and users. And note that validators here parallels the block producer role of miners in traditional proof-of-work networks like current Ethereum. The way we do this is through several incentive mechanisms, the main one of which is what we call the fee split mechanism. So for developers, we repurpose the EIP 1559 base fee in order to give Evmos developers a cut of the transaction fees that accrue towards the usage of the contracts they deploy, right? So on Ethereum, the EIP 1559 burns the base fee entirely, whereas on Evmos, the base fee is repurposed to award that base fee to both validators and developers, right? So as a developer, you can deploy your smart contract to Evmos, and based on the usage of that smart contract, have be able to reap a cut of that usage, right? So essentially, you're creating a cash flow for yourself by developing on Evmos, which can enable you to build out more sustainably without having to dilute ownership of the protocol by selling it to private interests as well. And again, this is kind of in the spirit of the community-driven approach that Evmos has so far embodied. In addition to that, we have 25% of the block rewards earmarked for what we call usage incentives. Now, usage incentives are different from the developer-focused fee split that I just talked about. Usage incentives are oriented towards users. For users who burn a large amount of gas on using smart contracts, they're able to get rebates on that usage through this mechanism right here. Contracts are whitelisted by governance, so the community essentially elects to vote on a contract that should be whitelisted for usage incentives, and users who interact with those smart contracts are able to make back some amount of Evmos tokens based on what's burned, or what they've burned. Essentially, rewarding the highest highest usage power users and enabling them to continue their journey of using Evmos dApps. So before I get to this, these two mechanisms combined sort of form the basis for the dApp store that I mentioned earlier. The developer mechanism specifically, the fee split mechanism, allows developers to earn a cut of the fees, much like the App Store that we're used to for when using the Apple or Android ecosystems, right? These cash flows can also be redirected towards funding public goods. So if the developer says, hey, I'm already generating cash flows through other means, but this specific developer incentive could be useful to fund the development of a bridge or to pay back the community pool, I can redirect my cash flow there. Now, the last issue that Evmos seeks to solve is the slow iteration. If we look at Ethereum's development timelines, we've seen timelines that take, they're on the order of magnitude of years, really. So topical here is EIP 1559, which was first proposed in 2019 and took 2 years after a few delays to really land back in 2021. Similarly, ETH 2.0, later renamed to the merge, has been in process, in the stage of implementation, testing, and rollout for many, many years, and we still haven't seen the merge land. It's slated for later this year, of course, but it's been 2 years away since, as far as I can remember. On the flip side, if you look at how much the Cosmos community has shipped to date, they've shipped features like IBC, superfluid staking, on-chain governance, CosmWasm, and fast finality proof of stake, to name a few. It's really quite amazing what the breakneck pace of the Cosmos ecosystem can really lead to. Future features that are planned for just later this year are things like threshold encryption, cross-chain NFTs, and interfluid staking. Now, recall, folks, that the Cosmos Hub has not been live for that long, and Osmosis really only launched as early as last year. Again, Juno launched earlier this year, I think, and Evmos also launched earlier this year. And already we've come a really long way as a community as far as all of the features that we've planned and shipped. Evmos specifically has shipped the features you see to the left, things that we didn't think would be possible as soon as they have been. So things like, bringing EVM smart contracts to Cosmos through Ethermint, but also, being able to support seamless integration of all the EVM applications that we're used to. Core protocol incentives that I just talked about with alignment in the dApp store. Cosmos compatible ERC20 tokens, so bringing things like USDC to the Cosmos, as well as tokens like Uni, USDT, etc. And Ethereum to Cosmos bridging, making token transfers and arbitrary message calls possible between the two ecosystems. In the future, you'll see multi-coin fees, liquid staking, interchain accounts, and validator fairness also come to Cosmos, which will sort of complete the feature set that Evmos has planned. In addition to that, there's been a huge talk about shared security, and this sort of goes back to the aspect I mentioned in one of the first few slides. I talked about the trajectory of dApps being able to build on top of Evmos and then sort of spin off into their own L1s, similar to how DYDX has done it. So Evmos shared security, and now shared security has been a huge topic in the Cosmos community, especially recently, with the funding of Neutron from the Cosmos Hub. However, Evmos also has ambitions to incorporate shared security, and I think there was a great presentation yesterday too. So if you're watching the recording for this, I highly recommend you check out the shared security presentation from yesterday. But for dApps who deploy to Evmos, they're able to gain traction and sort of exit Evmos in the form of a consumer chain, a consumer Ethermint chain, with Evmos providing shared security. Eventually, if they so wish, they can bootstrap their own validator set, but the point here is that shared security smooths out the transition with having developers not need to bootstrap their own validator set from scratch. Evmos will provide that validator set, that infrastructure to build on top of, so that developers will only need to focus on their core business logic. One last thing on this point. My colleague yesterday shared some of her work on trailblazing the EVM interchain. With the proliferation of many EVMs in the Cosmos ecosystem, it'll be important for smart contracts amongst those to be able to talk to each other seamlessly. Building on top of a single EVM chain in the future will provide both developers and users with an abstracted interface. It won't matter what EVM chain they deploy to, and in fact, in the future, folks will be able to launch EVMs with their own custom precompiles, so optimized for specific things like NFTs, NFT data storage, for example, basically these will all act as extensions to the same runtime, right? Again, focusing on the specific talk that my colleague gave yesterday, so on day 2 of HackATOM, I highly recommend you watch her presentation as well, titled Trailblazing the EVM Interchain. She demonstrated an environment with 3 separate Evmos forks running, where you could deploy to any of these 3 Evmos forks and be able to talk to the other chain directly. You could build a multi-chain dApp without having to redeploy the exact same contracts on each of the other chains. dApps on, I guess one of the chains is called Ethos here. dApps on Ethos can talk to dApps on Logos seamlessly. If you are interested in learning more and getting started with this, please watch the presentation and navigate over to the URL you see on screen, github.com/laurel/demos, and that'll contain all of the instructions necessary for you to get started. Now, if you want to get started with general Evmos development, you can navigate over to the docs, docs.evmos.org, or just evmos.dev. You can also find the explorers and get help at the URLs on screen. Generally, something to point out is that the .org TLD will point you to mainnet explorers, whereas the .dev TLD will point you to testnet explorers. And this is the same for our RPC URLs as well. Right? If you want to bridge over some liquidity to get started, Evmos supports a ton of bridges with a ton of connections to other EVM networks. Of course, I haven't mentioned it on the slide here, but you can always bridge liquidity over from other Cosmos chains. So Evmos supports IBC naturally. However, if you have tokens sitting on Ethereum, Moonbeam, Polygon, Gnosis chain, etc., you can bridge those tokens over to Evmos no problem with your bridge of choice. The canonical bridge that we like to use is Nomad in combination with Connext, but you're welcome to use any bridge that supports Evmos. As far as RPC endpoints and wallets, as I mentioned, Wallet Connect should work seamlessly out of the box, as well as MetaMask. So if you are coming from the Ethereum side, you can use either of those. If you're coming from the Cosmos side, you should be able to use Kepler, Cosmos Station Wallet, CipherD Wallet, etc. And that list keeps growing as more wallet teams add support. So I think next on the list is Leap Wallet. If you're used to using Leap, they'll be adding Evmos support fairly soon. In order to connect, you can go to the URL on screen, and we have a bunch of RPCs ready for you to use, both on the Cosmos side, so things like Tendermint, gRPC URLs, and on the Ethereum side. So you can also go to chainlist.org to connect your MetaMask directly to Chainlist RPC URLs. I'd also like to mention that in conjunction with this hackathon, HackATOM, we have the Evmos Momentum Hackathon, which is a month-long event hosted by the Web3 scholarship team. And so more details on that can be found on the dev post, or if you go to momentumhack.evmos.org, you can also find more information there. I think August is going to be the last day for the hackathon, and the prize pool there is 5 times HackATOM's prize pool for Evmos. So it's $500,000 worth of prizes. And again, of course, this event is hosted by, was sponsored by the Evmos community pool. Big thanks to the Huobi Web3 scholarship team also for making it happen, making the proposal to the community pool in the first place. Now, I'll pause here for a minute or two. If you want to enter the raffle, we have this QR code on screen. You can also come find me after the talk, and I'm happy to share this with you as well. One last thing to mention here is that Evmos also has a grants program, so if you're not satisfied with the prize money you win at this event, as well as the Momentum Hackathon, which again is a month-long hackathon running from July to August, you're more than welcome to apply for an Evmos grant, and you can find that pinned to the top of our blog at evmos.blog. Now, we also have a HackATOM raffle, so there's a lot of raffles going on. Again, if you don't get enough time to scan the QR code, come find me afterwards, and I'd be happy to share it with you. But enter the HackATOM raffle, enter the Evmos Momentum Hackathon raffle, 2 separate raffles, and double the chances to win things. All right, and that's it for this presentation. If you're a developer, I hope this has been compelling for you, and if you have any questions, I'm happy to answer them. I also have a very, very short demo of how you can get started with developing on Evmos. For those of you who are beginners to developing on EVM-based environments, this will be useful for you to showcase how you can get started. And for those of you with more experience, this will be useful to sort of demonstrate parity with other, with how EVM tooling works on other chains. But I'll pause for let's say 2 minutes while folks ask questions, and I can also maybe have the previous raffle QR code up on screen for you. All right. Alrighty, okay. So I think that's it here. Switching gears a little bit. How's that coming out? Okay. So here we have Remix, which is a tool that most Ethereum developers have sort of gone through and used early on in their Solidity development journey. For those of you who are just getting started, you can always, learn Solidity by Googling it or browsing YouTube. There's a ton of tutorials at this point. One of the benefits of leveraging, an environment with so much existing support is that everything you learn in tutorials, guides, YouTube videos, etc., all of that is portable over to developing on Evmos as well. So I'm not going to do a tutorial on what Solidity is or how to write it. There's also, if you prefer other languages of choice, you have Viper, there's Huff, and my very own colleague Loredana, who again gave that talk yesterday, has developed her own language, Taylor, which you're welcome to check out as well. It'll be in that same repo by the Laurel. So what I have on screen here is Remix, which again is that tool that many developers use for quick iteration and development. And what it is it's an online IDE. So folks can use it for quickly deploying smart contracts to either a local simulated environment or a live network. And you'll see that I have the network pointed, the IDE pointed to my MetaMask, pointing to a chain with ID 9000. Now, chain with ID 9000 is in fact the Evmos testnet. All right, and again, if you are curious on how to add this to your MetaMask, you can do so by going over to chainlist.org. So we can try do it as well, turning this on and looking up Evmos. And here we go. This is Evmos testnet 9000. You can just connect your wallet and it'll add the network to your MetaMask. Of course, the Evmos mainnet is chain ID 9001. In any case, you have an option here to select many different providers. We're using the injected MetaMask provider, but if you're running like local tooling like Foundry, you can also plug Remix into Foundry. You can run a simulated in-browser environment as well. But yeah, so we're pointing to the live network. And what we're going to do is we have this Open Zeppelin contract, this ERC 721 implementation, which is basically a simple NFT smart contract, and we're going to deploy it to the network. But first, we need to seed our account with some tokens, and that's as easy as pulling some tokens from the testnet faucet. So I have the faucet account loaded up here, and I'm using Kepler here to demonstrate how easy it is to use any tooling that's out there to get what you want done. So we have the faucet with a high amount of tokens, of testnet tokens, and what we're going to do is we're going to no, why is it an invalid address? So we're going to actually do this. What's that? No, I guess the Explorer is displaying the address incorrectly here. But what we're going to do is we're going to send 500 tokens to our MetaMask account from the faucet. So we're not using the faucet to deploy any smart contracts. We are going to use the MetaMask account. But I'm using Kepler to send over these tokens in the first place. So we're just going to wait until the transaction is processed. and we should see the tokens show up. Oh, there you go. Show up on the demo account on MetaMask, right? So interoperable tooling. Now, let's see. So we have 500 Ether here. Well, it should be test Evmos. It's just that Remix is hard-coded to use Ether. And what we're going to do is we're going to deploy our ERC-721 smart contract, which again is an NFT smart contract. So we're passing in as input, so just to show you, the input here takes in a name and a symbol. And yeah, that's all we're going to do. It also, I guess, takes in a base token URI, but we're not going to use that. So we're passing in as a name HackATOM token and with the symbol hack, and we're going to deploy our smart contract. Just going to confirm that on MetaMask. And once the transaction has gone through, we'll be able to manipulate things like NFTs and sort of mint new ones and such. So our transaction has gone through here. Let's see if it shows up on here. No, I guess, yeah. I guess this is not the correct. Let's see if we can search up. Oop. Nope. Let's copy it back here. Ah, there you go. Okay. Not sure what the difference is there, but you can see here that, again, MintScan is usually a Cosmos-focused explorer. However, it's displaying Ethermint transactions here as well, right? So we can see two transactions have taken place. One is the transfer that I did. The other is the smart contract deployment on the testnet. And Remix is really nice because it lets you input, it lets you call any of the available public methods with any arbitrary input you'd like to pass in. So what we're going to be doing is we are going to mint an NFT. And again, we're going to just take this address here and pass it in as the owner of this new NFT. What we can do before that actually is we can query the smart contract to see if it's been set correctly. So we can query the name, and the name comes back to us as HackATOM token, of course. We can query the symbol, and the symbol is hack, and we can query the total supply. So how many NFTs have actually been minted here? And we see that the answer is 0, right? But let's change that. So we are going to mint a new NFT with the assigned owner being the demo MetaMask account. And so again, I'd need to confirm on MetaMask, pay for my transaction. And once it's confirmed, we'll be able to check the total supply once more, and that's changed to 1 now, signifying that the token has been minted. We can also check for who the owner is of a specific ID. And obviously the first NFT minted will have an ID of 0 since it's 0 indexed. And that should give us back my address, which matches up to the demo address, D19B, D19B. And yeah, that's how you can get started developing on Evmos. It's as simple as doing what you would do on Ethereum. And if you're at this point of, if you're a Cosmos developer and looking to start, then feel free to come ask me questions or look up any guide that focuses on Ethereum development, and it'll be much the same. Thank you very much, and that's it from me.
All right, we're going to get started for my talk, which is going to be a little bit of a shifting gears from what we've been talking about and have had presenters speak about. So when Daniela, who, by the way, congratulations to Daniela and Erica for this incredible event. It's been really a pleasure and an honor to be here. So when Daniela sort of asked me to speak today at the HackATOM in Seoul, I was reflecting on sort of being in this position, sort of, building in Cosmos. Maybe you're a beginner, maybe you've been around for a while, but I was reflecting on sort of all of the organizations, all of the entities that come together and really end up building all of this incredible technology and all of these systems that, as end users, maybe we don't fully sort of know kind of who is behind. And so understanding that there's a lot of human organizations, a lot of entities building this technology, I was reflecting on sort of, as a participant in this HackATOM, how would I, if I was a participant, build my career in Cosmos? How would I launch my career in Cosmos? So that's what I'm going to talk about today. Hopefully these are some useful practical lessons and something that can help you really take off in Cosmos, build an incredible career, and really succeed. So I'll first start off by introducing who I work for, the company that I represent. So I work for Informal Systems. We're a core developer of Cosmos. We're a research and development organization. Most of our team is technical. I would say about 80 to 90% of our team, either researcher or engineer. I work on the non-technical side in product development, marketing, go-to-market, business development, things like this, really helping to bring the products, the technology that we build to market and to a wider group of users. So very briefly, we work across 3 dimensions. So first, we do build applications that maybe aren't as much user-facing, but they are very much used by technologists and engineers to improve the quality and security of their systems. One example is Appalachia, a model checker that we also leverage in our audits to prove the correctness of the technology that we build. We also run infrastructure, so we build and operate nodes and relaying software to power the interchain. My colleague Dan earlier talked a little bit about Hermes, the relayer that has become widely adopted for relayer operators. We also run a validator called Cephalopod. Cephalopod is active across many networks, including the Cosmos Hub, including the Regen Network, Osmosis, and others. And then lastly, but definitely not last in importance, is the Cosmos Hub. So we develop features for the Cosmos Hub to serve the interchain in a sustainable way. So one of those features that I'm working on is interchain security. It is the next sort of phase, evolution of the Cosmos Hub, if you will, that will really build out the hub as this application deployment environment, really help app chains scale, launch securely, efficiently, and things like this. So that is who the organization that I'm representing today. But instead of talking about Informal's work or again some of the things that I mentioned that we work on, we're going to talk about building your career in Cosmos. And again, hopefully this is useful information. And so let's begin. So I'm going to start off by introducing myself. I do think that when we talk about kind of career development and launching your career, it's important to kind of understand the motivations and the reasons why we take on the roles that we do. So a little bit about me. I started off at Informal about two and a half years ago. I've always been fascinated with systems in transition, to put it bluntly. So in university, I studied political science, economics, and actually did quite a lot of field research in post-conflict societies. To me, post-conflict societies and actually societies that are still undergoing conflict sort of represent, a really, kind of perfect case study, if you will, of what happens when things break down, when trust, communication, and really when social bonds break down. And so throughout my studies and even through my work, I had the opportunity to do field research. So for example, I conducted a field research project in the Balkans during the Syrian refugee crisis, really understanding how, in the absence of institutional support in the absence of governmental support, what happens when communities have to self-organize, when they have to come together and provide the care and the resources and the support that is needed to transition out of those horrible depraved situations. So that was ultimately my motivation, from as a young child, as a student, starting my career. I was always interested in this ideas of community self-organizing, which really does kind of play a role into the motivations and things that I will sort of ask of you who's considering building your career in Cosmos to kind of reflect on. What are these motivations? What are these concerns that you hold so deeply, so dearly, that motivate you to take these risks, build your career, in a way that makes sense for you philosophically, personally, emotionally, professionally, and so on. And so this was really a lot of my motivation in university, again, in my career. How do communities self-organize? How do these grassroots efforts take shape? When do they succeed? When do they fail? And how do we get out of these sort of transitory moments? And so that took me to a more, let's say, formal sort of organization or a more formal role in the realm of political advocacy. So after I completed this field research, had a couple of roles where I was working in more of these post-conflict sort of scenarios. I came back domestically, back to Canada, where I'm from, and was very interested in political advocacy. So I worked for an organization, an industry association, which represented business interests in Canada, specifically technology companies, and was really advocating with the government at that time on how do we effectively make sure that smaller companies, smaller tech companies are of an equal footing as larger tech companies, the Facebooks, the Googles, the big tech companies. And so again, there was similar motivations, although the role was very different, and it was a different context, it was a different, let's say, mission. It was a very similar sort of desire or motivation, which was how do we effectively communicate in this case, a minority interest, or at least an interest that wasn't as powerful or, well regarded as something like, the Google lobby or the Facebook lobby in Canada. And so, really working with a small team, working, in a very agile, fast-paced environment, we were able to effectively lobby the government for these interests, and that's really how. That was actually my last role before I got into the Web3, the crypto space, full time. So we're going to go into a little bit of a thought exercise, a moment of reflection, for all of you that I really encourage you to kind of think about. But for me, ultimately, what I realized before I sort of, jumped headfirst into crypto and Web3 was, blockchains, as I was, studying them, reading the Bitcoin white paper, starting to go to meetups, starting to, meet people that were dedicating, their career to this, I realized, blockchains are in fact political economies themselves. They're obviously, incredibly technical, systems that, require a lot of, engineering work. They require a lot, standardization frameworks. They, there are a lot of technical considerations, of course, but at the end of the day, these are political economies that will, in one way, shape, or form, for years to come, influence the way we think about economic relationships, the way we think about probably political organization, political organizing, and so that was kind of the epiphany that I had personally, going from university, studying, post-conflict societies, political science, economics, into my career of political advocacy. It was my realization at that time that blockchains are political economies. This is where I want to be, and I've been very happy ever since. So. That's a little bit about me, but I do want to throw out a few questions, a few things to consider to all of you that are looking to land your first role in Cosmos specifically, and hopefully this will help you navigate this very complicated ecosystem. If we're being honest. So, landing your first role in Cosmos. So there are three things that I think everyone should actually ask themselves whether or not you're looking to join to build your career in the cosmos or elsewhere, but one is how do I want to work? Why do I want to work, and where do I want to work? We'll look at these 3 questions in order, and we'll apply them to the Cosmos ecosystem. So first, so a career in Cosmos. There are a few ways that these questions could be answered. So how do I want to work? There's obviously many ways of contributing, of starting your career. I mean, being here is obviously one way to sort of kickstart this process, but there's different ways. One, in terms of the how, is open source contributions, applying for grants, becoming a full-time employee, a contractor. This is really the structure of how you would work day to day. Some people prefer more of a kind of regimented, formalized schedule. Other people are very comfortable with being independent, not having to work within a traditional corporate structure. So the how is really about how you think about your place of work, the environment, your day to day. It's very a practical consideration. The why is where it gets interesting. From my opinion, because this is where we start to kind of consider the motivations, more of like the philosophical sort of thinking behind what motivates you personally to do the things you do. Our time is precious. There's always trade-offs when we decide to take a certain path. So some examples, in Cosmos specifically, why do I want to work? Maybe you're motivated by mass adoption. You could have any, maybe any role, or at least the role itself isn't super important, but you care about the outcome, the objective, right? So you really care about the technology. Maybe you care about the, philosophy, and you're just interested in seeing this be, adopted in the real world. People are using it. You care that there's activity, there is interaction, engagement with the technology itself, and so that's why you're interested in a specific role. Maybe you just really care about solving technical problems. Hopefully, obviously, these technical solutions result in mass adoption, but maybe the motivation is just being an expert in your field, being solving hard problems, hard to find bugs, and that's your motivation. Or maybe it's actually more sociopolitical. Again, maybe it's just something that motivates you from more of a philosophical angle. So these are just examples, when you start to consider why do I want to, have a specific role, why do I want to even be active in the Cosmos ecosystem in the first place, you start to consider, some of these things, and, obviously this list is not exhaustive. There's many reasons why you would want a certain role, but these are just sort of some examples that come to my mind at least. And then a career in Cosmos. So obviously, Cosmos is this ever-expanding internet of blockchains with many different entities, companies, individuals, projects, all working towards this vision of an internet of blockchains as a sovereign, interoperable ecosystem of many app chains communicating, transacting with each other, which resembles quite like the internet of today. And so where to work is definitely a big question. Similar to the internet of today, there is no one internet company. There are many internet companies, and it's similar in Cosmos. There's no one Cosmos organization. There's no one Cosmos company. There are many organizations. And so after sort of asking yourself these questions, how do I want to work? Why do I want to work? Hopefully you get closer to the where. You find your organization, you find your people, your tribe, your project that really motivates you, inspires you to carry out your best work. And so In Cosmos, there are many different layers of organizations. This visualization of map of zones, it has come up, many times throughout this hackathon in different presentations, different contexts. And in my context, for this presentation, it represents actually one layer of organizational structures, right? So if you think of individual layer ones, individual app chains, they themselves represent at least a collection of organizations that all work in service of those layer ones, of those app chains. So this is one layer, but I would argue this is a very abstract layer that doesn't really get to the core of, kind of the entity or the organization or again, the group of people that are really responsible for stewarding and shepherding these projects. So there's layers and layers underneath this sort of visualization that, again, in my opinion, is still quite abstract and doesn't really get to the human sort of core of, what is kind of happening behind the scenes to make this a reality. And so there's different, sources, resources in the community on, core contributors, different entities working, again, in service of these different projects. There's no one canonical sort of frame of reference because the Cosmos and the different organizations contributing to the Cosmos are ever expanding. I mean, even this weekend there will probably, if I had to bet, be a new company or a new organization or a new entity that is formed around a project. But this is just one example that also, I think, represents like a really great ethos in Cosmos, which is, independent contributions and resources and research which can be put into the community, updated in an ongoing fashion that just, represent, a snapshot or at least a state of how things currently are. Thank you. And so here, specifically, this is a core contributors, specifically core contributors for Cosmos and the Cosmos Hub. So these are organizations which work to shepherd a lot of the technology that the Cosmos Hub is shipping. And this was actually put together by an independent community member, put together by someone that was just really passionate about the ecosystem and just wanted to put out a lot more knowledge and education on where the activity is happening. So as I mentioned, there's a lot of complexity. I think when you kind of enter Cosmos, there's different layers of organizations. I mentioned there's like this abstract sort of notion of all the different app chains, that are represented in map of zones, connected via IBC. And so how do you navigate that complexity? How do you, as somebody that is interested in, building your career in Cosmos, working full-time, working, long, for many people, long hours, how do you navigate this complexity? How do you make the right decision for yourself on where to build your career? So I would argue there's, 2-3 sort of approaches to how you think about navigating this complexity. And it really, I think, depends on probably your character, probably your experience, probably sort of your personal philosophy, preferences on which approach you take, not one or, no one approach is better than the other. It really just depends. But this is a way to maybe categorize those approaches. So the first approach is more of a grassroots approach. And I would argue this is actually maybe more common in Cosmos because it is such a active, decentralized, open source culture where there are many different ways of sort of contributing in a grassroots fashion and then becoming maybe more formal down the line. But for this grassroots approach, practically speaking, they could mean open source contributions, pull requests, opening issues, just a way to show that you're following what is happening, you're giving feedback. There's also self-initiated projects. So this is similar to kind of what I just showed here, a project that was put together by a community member that was tracking core contributors and their work in real time. This is something that you feel very passionate about. It could be something that maybe you put together actually at a hackathon. It could be something in your spare time. It could be a front-end project. It could be a research report. It could be, there's really no limit. And then I would argue on-chain governance participation is also quite grassroots. So it really forces you to make, connections with, validators, community members. It really forces you to understand the Cosmos governance process. And so this is another grassroots way of really getting involved in the ecosystem, really starting to understand, who is responsible for what, and how you can make a contribution and how you can, really, succeed in this ecosystem. And then there's the top-down process as well. And if this is something that you're maybe more comfortable with, this is the standard application process. What is a company that is hiring? Are there organizations that have recently raised money, that have resources to support your career development? Does the management or do the people that work there align with your values? This is obviously the standard way that most companies operate. But then there's also always the in-between. There is the more flexible arrangements, contract work. There are also opportunities for grants. You have a partnership, you have deliverables to account for with a specific entity, but you're still independent. You still have that flexibility of moving around, maybe switching gears. And so there is that in-between, the grassroots sort of bottom-up process, and then the top-down sort of formalized hierarchical process. And I think, after everything that we've talked about so far, at the end of the day, it is what outcomes do you want to see in the world? What are the things that concern you, preoccupy you, that you are really passionate about? Maybe that is product design, maybe that is, developer relations, maybe that is marketing, maybe that is, engineering. It really depends what outcomes you want to see in the world, and really the role that you end up sort of taking on would help facilitate those outcomes. So let's say you are someone that is really interested in developer relations. Maybe the outcome you want to see in the world is just mass adoption, education, clarity of thought. You care about documentation. The outcome that you want to see in the world is, easier to understand, experiences when it comes to using this technology. And so you can get as specific as you'd like when you start to answer these questions, but it's constantly asking the what, and making sure that those outcomes and those concerns are well communicated. And this is actually something that myself and others actually at Informal practice a lot. So constantly having those discussions. What outcomes do we want to see in the world? What are the things that concern us? How do we work towards them? They can be as abstract, as far-fetched, or as specific and granular, as you'd like. And so I will actually end with this poem. This is actually only a part of the poem that I could fit onto this slide, so I really do encourage people to read this on their own time. But Peter Denning is a software engineer. This was actually published in a technical journal, I think the Computers of ACM journal. So this is actually more towards an engineer's mindset. And so when he put this together, he was reflecting on the complexity of the systems that are being built, the technical difficulties, the toil, the pain sometimes. And so he was reflecting, how do we get beyond these bumps, right? We come at a crossroads, we feel the pain we feel the difficulties, and so how do we acknowledge that, and how do we move forward? And really the intention behind this poem is to consider yourself a beginner in everything that you do. You might be the world expert on Tendermint, on distributed systems, on the Cosmos SDK, but inevitably there will be points where you reach an impasse, where you reach a moment where you might want to give up. And having this mindset of a beginner, almost like a childlike perspective, that there is more to discover, there is always more to learn, almost the sense of humility, I think is really powerful. So, I am a beginner, I am entering a new game about which I know nothing. I do not yet know how to move in this game. I I see many other people playing in this game. This game has gone on for many years prior to my arrival. I am a new recruit. I see value in learning. So it's this idea of having a beginner's mindset, being open to novelty, to new perspectives, to new experiences, and really understanding that there is a lot more to be learned. Even if you've been around for a very long time. So I hope it's inspiring. I do encourage people to read the rest of this poem. Again, this is just one verse. So closing thoughts, Cosmos is awesome. I really do hope that some of you here today will decide to build your career in Cosmos. Again, there are always trade-offs. There are always other sort of ways of working, or other organizations, other projects to work with. But I really do think understanding how to navigate complexity, understanding how you want to work, why you want to work, what you want to work on, will definitely help you to really succeed in Cosmos and building your career in Cosmos. And if you have any questions, I'm always around and really happy to discuss any of these things further. So thank you.
Uh, uh, yeah. Hi everyone. This is Bums. Hi everyone. This is Bumsu Kim from Constellation Network. Uh, First of all, I have to say that I have huge respect for everyone here who has devoted your precious time for this hackathon, and it's my true pleasure to be able to present our project in front of you passionate engineers. So we are also a team of passionate builders, and we constantly build things to solve some important problems, and we improve them through repeated trials and errors with the spirit of Beetle. So in this presentation, I will introduce what we do, and hopefully you will find them interesting. In this presentation, I will first tell you about our motivation to develop our own mainnet, and then we'll also have a look at our ecosystem project, and then finally there will be our roadmap for mainnet development. So first, Constellation Network. Constellation Mainnet is a layer 1 blockchain protocol developed with Cosmos SDK. So our vision is to create a global and scalable infrastructure for finance users and industry. So many of our members have backgrounds in finance industry, and we've ourselves encountered like many inefficiency and inaccessibility issues ourselves. So these kind of experiences like motivated us intensely, and so we are trying disrupting finance field and making real world impact using blockchain technology. So probably most of you would simply easily agree that the consequences of blockchain development would be so big that in the near future, like it will change the everyday lives of normal people. However, like it's still true that the vast majority of people in the world have not experienced tangible impact of blockchain. So to them, the promises of Web3 innovations such as decentralization, trustlessness, and composability could sound somewhat far-fetched. So our approach to the problem is to simply provide a bundle of applications and infrastructure all together, rather than providing only a single piece. So since we are still in the early stage of blockchain development, for normal users, like combining different pieces of features on their own to use some DeFi like features could be painful, and they may find it hard to find any utility. But by providing a whole package, like we believe it becomes a lot easier to appreciate the true value of blockchain technology. But it goes out without saying that Constellation Network will still work as a key actor in this ecosystem. So the current near-term vision of Constellation Network is not very difficult to understand. Our goal is to provide one asset type with maximum interoperability, which is dark. So we aim to make it liquid and accessible from anywhere a bit can go. So yeah, so this may sound too simplistic for some of you, and some of you may see as a special solution for some special problem. But actually, we believe our approach can solve a wide range of problems when properly configured with existing solution in each blockchain. So for example, with Dark being interoperable, it's actually possible to implement general cross-chain swap features by combining DEXs on each chain. So we have a step-by-step plan for improving the bridging feature. The first being connecting to Cosmos blockchains, the second being bridging heterogeneous blockchains, and the third being bridging Web2 and Web3 world. So the details of them will be discussed later in this presentation. Now, constellation ecosystem. Again, we are an ecosystem builder who is working both on infrastructures and applications for end users. So with the constellation ecosystem, users can easily invest in digital assets spread across various blockchains, and users can mint a wide range of fiat-pegged stablecoins, and users can explore different NFT trading chances, and they can also participate in a play-to-earn game and DAO. So let's see more details of each. So first one is Tabit. Tabit is a decentralized forex platform powered by a multi-currency stablecoin protocol called Alchemy. So basically, forex is the largest financial market in terms of daily trading volume, but it hasn't largely been connected to the Web3 world yet, I will say. So forex market is huge because the need for trading local currencies is always there. And we think that will be similar in the crypto market as the industry make more real-world use cases. Tabit will offer various forex-related products like futures, options, CDFs, which are similar to perpetual futures in crypto. Yeah, and now it is being built on Solana, and it's currently available on DevNet. Alchemy Mint is the first multi-currency stablecoin mint protocol with a shared collateral reserve. It is based on both endogenous and exogenous collateral by utilizing native hybrid algorithm system. So it practically means that when you are minting some Alchemy stablecoins, you need to provide both Alchemy's algorithmic coins as well as some USDCs. Alchemy's vision is to ensure that any new stablecoin associated with an existing fiat currency can be minted utilizing a single reserve. And we still want the new stablecoin to enjoy the same level of stability as the other existing stablecoins. So that's what we are trying to achieve. And so I have to also make a note here that there is a strong virtuous cycle between Tabit and Alchemy. So to become a useful stablecoin, there should be large enough demand for the stablecoin. In our case, Tabit is the first significant use case of multi-currency of Alchemy, and Tabit users can trade with their own local currency stablecoins. And also, strong derivative market will have a reinforcing effect on the spot market. So in this sense, deep spot market liquidity will naturally result in more trust in the system in Tabit. And as mentioned before, we believe local currency stablecoins and the forex market will be an essential building block for expanding the Web3 industry for the world. And the next one is carbon credit trading platform. So under the 2015 Paris Agreement, many countries agreed to cut greenhouse gas emissions in order to stop increasing the global average temperature. In carbon credit, there is the mandatory market where companies trade credits generated under the government's control. But there's also the voluntary market that is getting more and more attention, in particular after the Paris Agreement. So carbon credit is one of the most promising asset classes, but it lacks an organized platform where participants can effectively invest in the various carbon reducing projects in different stages with different risk profiles. It is also beneficiary to the credit providers as our platform is a new source of capital. To attract qualified carbon credit projects and design a platform in a manner that market participants actually desire, we started a partnership with an expert carbon credit issuance agency. Our project team is building a sophisticated verification and classification system to provide qualified and reliable carbon credit. And finally, VegaX. So VegaX is one of our most successful projects and is one of a digital asset management company creating a investment product for medium and large scale investors. Our main target clients are people with relatively little experience with the Web3 technology, but still wanting some crypto exposure. In particular, VegaX makes crypto portfolio management easy by offering well-structured investment products like covered calls, enabling the clients to significantly improve their returns. Our strategies are based on the indexes we design. This kind of approach is actually quite popular and common in traditional finance, but this is something that's still largely missing in crypto world. So each index reflects a certain sector well, and it helps our users make systematic and principled investment decisions. Currently, Vega is mostly relying on CeFi services since they have the most rich set of assets and largest liquidity at the moment, but we are also exploring new realms such as DEXs and non-custodial on-chain asset management using smart contract, which will be discussed in our roadmap too. So yeah, up to now, we've explored some of our important ecosystem projects, and we believe each project has its own strengths. But at the same time, each of them induces synergy within our ecosystem too. And Constellation Network will contribute to the whole ecosystem by providing maximum interoperability and governance features through a dark token. And it will work as a important bridge. Yeah, final section is our roadmap for our mainnet. So the first phase of our roadmap is connecting Constellation Network to other Cosmos-based blockchains. Please keep in mind that one of the main goals we wanted to achieve with Constellation Network was to use it as a scalable bridging solution. So why does it make sense to use Cosmos-based blockchain for cross-chain bridging IBC? So one thing that is obvious is when you're developing with Cosmos SDK, IBC is basically enabled by default, so you can conveniently connect to other networks, Cosmos-based. Also, deterministic finality of Tendermint was another important consideration. Bridging two heterogeneous blockchains is a pretty complex task, and having a ledger with deterministic finality for the bridging significantly reduces development effort. And so it makes a lot of sense to use Tendermint to build a bridge, I would say. And if Constellation Network were based on probabilistic finality ledger, then the entire process should always be probabilistic, which makes it tricky to cover all edge cases. And finally, the fact that various financial functions can be added through smart contract or upgradability during the bridge process was an important and attractive factor in our decision. And the rest of them are basically the common steps for developing Cosmos-based blockchains. So our mainnet is currently IBC enabled with Cosmos Hub, Osmosis, and Juno. And there are 70+ validators at the moment. And it keeps getting more decentralized. And we have developed our own Explorer and wallet. And the native token of Constellation Dark has been listed in Osmosis, MEXC. And it made it much more liquid and easy to access. And this phase has actually been largely done. And of course, there will be, we are still planning to improve the existing features by connecting more Cosmos blockchains and by improving our existing features. And the second phase. So this phase is a work in progress, and please note that there could be some changes by the time we finalize all the feature details. So in this phase, like our main focus is bridging Dark to other blockchains such as Ethereum, Solana, Binance Smart Chain. Please note that we are not focusing on bridging assets other than Dark in the near term. This makes it like significantly easier to develop and audit because like we are only like bridging one asset and it's one thing to take care. But bridging only Dark does not mean that it is the only beneficiary for Dark holders. So it is actually almost quite easy, I would say, to combine Dark bridging feature with each blockchain swap features. So for example, if you have some USDC, you can first convert it into Dark and proceed with the bridging and then convert it back to USDC on some other destination network. So you can imagine that kind of scenario. Okay, now let's compare our approaches with some other popular approaches. The first thing we compare Constellation Network with is Thorchain. So most notably, Thorchain is a swap solution, not a bridging solution. It means that the kind of token you're sending is always converted into something else. So it's simply a different approach. And Thorchain mostly focuses on swap and AMM logics between different networks, and it has their own AMM liquidity pools, which makes their native token rune more attractive in a way. But at the same time, they are not utilizing the largest liquidity of each blockchain, such as the one in Uniswap. So in our case, we can simply rely on each blockchain's largest liquidity pools. And the other one thing we can compare is Wormhole. So Wormhole is a widely used bridging solution and is specialized network for low-level messaging interactions. So it is designed to bridge an arbitrarily many number of assets. But on the other hand, like we are only focusing on one asset, so it's different. And Wormhole is serving the purposes they were designed for well, I would say, but one limitation of them is that they are not general purpose blockchain with smart contract enabled. Also, it cannot utilize various features from different Cosmos-based blockchains through IBC. So this is a little detailed mechanism of our bridge functionality we are aiming to deliver in the end. So here we use Constellation nodes themselves as relayers. The scenario is a user is sending Dark from one source network, which is not Constellation, to a destination network, which is not a Constellation network again. There is a port contract in each side of the networks, and the port contract has a right to mint or burn wrapped Dark when certain conditions are met. So once a user sends a token, let's say token X from a source network M to the port contract in the destination, to the port contract in the source network, then the asset is locked and the corresponding special logs are generated. And then the Constellation network nodes listen to the logs and process the event with the financial functionality. A little detail omitted in this illustration is that technically there will be a separate event listener running independently to detect new logs for each node. An example usage of financial function could be pulling from the price oracle of osmosis to adjust the fee amount based on the information. So the process result is then signed by each node, and once there are enough number of nodes that confirm the bridging, Constellation client collects the signatures and finally call the port contract instruction on the destination network. And the port contract checks if the instruction is valid and corresponding assets is finally unlocked on the destination network and sent to the user. And this is the final phase. So here we will provide some more long-term goals of constellation network, and this phase is actually not just about breaching dark, one asset. So although Web3 is definitely a consequential innovation, Web3 alone cannot solve every problem we have. Human beings have accumulated a large amount of legacy in the Web2 world, and there will be a lot of things that can be handled better in Web2. So yeah, also like connecting Web 2 and Web 3 is indeed technically challenging, but we should also take care that this is not only a technical problem, because like it will require cooperation from the Web 2 actors. One of the things we want to achieve in this phase is connecting real-world assets into blockchains. That is, of course, a daring challenge, and we are still open to many different approaches. So we can either try to make Dark to have real-world use cases, and we can also implement native swap features between Dark and fiat currencies. Whatever approach we take, there are some conditions that should be first satisfied. So there should be large Dark liquidity pool, and there should be some open access to Web2 transaction history data, and also like it should be possible to make a permissionless to make an order in Web2 in a permissionless manner. So these kind of things will require Web2 operators' help. Yeah, another thing we want to achieve in this phase is decentralizing asset management. So the promises of DEX are, of course, very appealing. And there are like still many good things about centralized exchanges still. They are working as an important fiat gateways, which means users can convert their fiat assets into crypto assets and vice versa. Also, there are like rich set of crypto assets available. So the question here is that, is there a middle ground between CeFi exchanges and decentralized asset management? So when you utilize smart contract, it's not very difficult to provide only trading strategies to the users without taking their custodies. So if a user only wants to use DEXs for his or her trading, using smart contract, this is not basically very hard. On the other hand, at the moment, there's no easy way to trigger orders on CeFi exchanges from any blockchain using smart contract. So our ultimate goal is to develop a general purpose general standard for triggering CeFi orders from blockchains, and let CeFi exchanges can easily use the standards to connect our blockchain to their service. This, of course, will require active cooperation again from Web 2. Anyway, we believe our end user can enjoy a variety of high-performing strategies for many different use cases by using decentralized asset management solution of us. And this is the end of our roadmap presentation. Oh. Sorry, I was lagged. Yeah, and here is our team members. And there are actually many more members that you are seeing here. And we have many members from different industries and different places from all over the world, basically. So if you're seeking a work environment where everyone is an active builder and everyone is not afraid of learning through trials and errors, and if you are seeking on where diversity is respected, I believe Constellation Network would be a perfect fit for you. And if you're interested, feel free to reach out to any of us. And yeah, this is the end of my presentation, and thanks for listening.
Hey folks, how's it going? All right, let's talk about building on Stargaze. All right, I like to first start off with talking about the numbers. So let's go through some of them. So there's been over 420 collections launched on Stargaze so far. The launch pad started in March. On March 11th, we started with around 10 or 11 Genesis projects, and it's grown to over 420 projects now on Launchpad. So that amounts to something like 700,000 NFTs. Sorry for people who don't like NFTs, but this was one of the first in Cosmos, and we made NFTs a thing in Cosmos. So far, from the Launchpad, around 50 million stars has been paid to creators. And these are mostly independent artists. So Stargaze is actually kind of living up to the crypto ethos of getting normal people into crypto. The marketplace launched in May, and so far it has paid out 4.5 million stars in royalties to creators. Stargaze also the blockchain has 100% uptime. It's only gone down whenever it has to do upgrades. Also, the RPC service that powers it has handled over 3.5 billion requests a month, and that also has 100% uptime. This might come surprising to some of you. It was surprising to me, but Stargaze it comes in third in developer activity in all of Cosmos. So it's Osmosis, Cosmos Hub, and then Stargaze. In terms of IBC volume, it ranks in first when it comes to IBC in to IBC out ratio. So when people come into Stargaze, they don't leave. So it's kind of sticky. It's doing more volume than NFT marketplaces on Ethereum and Tezos like Rarible and Hic and Nunc. And it's also doing more volume than some major blockchains like Near with a fraction of its funding. So I thought today we'll talk about some of the projects and tools that are building on Stargaze that are like not made by the core team, and just kind of highlight some of them. Hubble tools. So if you're an active trader on Stargaze, you usually have the Stargaze site on one tab, and then you have Hubble tools on another tab. So the way to think about it is like maybe Coinbase and Coinbase Pro. Hubble tools has a live mint tracker, live sales tracker, live listings tracker. So it's almost like a real-time kind of trading environment for NFT traders. It also has some nice features like a whale wallet tracker and sales volume data. How Rare API. This was an API built by some of the Genesis creators. And it basically scours IPFS for all the data and rarity and traits, compiles them all together, and this is what powers Stargaze.zone's rarity data. Constellations. This is a project I'm very excited about. This is a high-performance indexer in Rust. Is built on Tendermint RS by Informal Systems, and it's providing a really nice GraphQL API that's going to power some of the features in the front end. Like sales history, trait filtering, and so on and so forth. Built by a validator called Penso. So delegate if you guys want to see this move faster. And yeah, it can process like 80 gigs of block data in 30 minutes. Stargaze Studio is another project that's been worked on. This is by Deus Labs. And it's basically a UI to enable artists to easily upload their assets and launch a collection. Because right now you kind of have to play with the command line, and that's not really friendly to some artists. And now I'll talk about some of the NFT projects that are building on Stargaze. Now, there's so many of them, obviously I can't cover all of them, but these are some of the more interesting ones. PS Labs. PS Labs is an Xterra project. There's a handful of Xterra projects that are building on Stargaze. The way this works is they launched a collection called X tokens, and it's like an access token that gives you access to their AI lab, which is kind of like a DALL-E-like service where you can go and mint your own NFT. And they made this little video that I'll show. And we didn't have any kind of dev fund or anything like that for Terra. They just came to us and started building on top. So they keep pushing the boundaries of what you can do with this stuff. They have another new project called O tokens that's coming out that makes you kind of do generate more complex AI NFTs. Space Ape Society, another Xterra project. It's a kind of a derivative project, but the art is different and interesting. They built this thing called a swap shop where you can send two apes to one address, and then it burns them, and then it gives you a new ape from their vault that hopefully is more rare than the ones that you put in and burned. And there's a bunch of projects that tend to want to do similar stuff. Stargaze's NFTs, they built this like really cool pixelated banners, and nearly every Cosmos chain has this in their Twitter bio or any social media that has some kind of banner, and it really kind of brought the ecosystem together by having all these chains have these banners up. And this is something that's kind of unique to Stargaze. It seems like a trivial thing, but we as the Cosmos ecosystem can say where we started the whole NFT banner kind of thing. This doesn't exist on Ethereum or anywhere else. They did this really kind of fun thing where anyone who had a banner got airdropped rockets and rocket fuel. And if you have two of these and you burn them, then it generates this really cool kind of cyberpunk cosmonaut PFP character. And the website is pretty neat. It's also kind of like retro 80s design, where you can go and put the rocket token ID, the fuel token ID, and click on mint. Then Coupler comes up, and you get your cosmonaut. I didn't want to do this real time because demos never work on stage. But yeah, that's Stargazer's NFTs. Multiscape is another banner project. This one's a little different. They have these collections of layers. These are all kind of like vector art. And then kind of a similar deal. You can combine them. You can combine two layers and mint a new one that combines the metadata and generates a new NFT. Puzzlers is kind of interesting. It's an actual little puzzle game. That's so let me actually try this live. Let me click on here and see if it goes to the website. And I'm going to try and solve this puzzle in front of you guys. Okay, never mind. But yeah, that's a fun little thing. There's a bunch of DAO projects that's building on Stargaze. All these NFT projects have DAOs, but there's no native DAOs on Stargaze yet. It's definitely coming. But to get around that, they're voting through the memo field. So if that's not product market fit, I don't know what is. All right, now I'm going to talk about Launchpad v2. So we're not just resting on our laurels. We keep improving everything that we build. And And Launchpad v2 is a CosmWasm framework for custom minters. So right now, Launchpad is really kind of focused on these generated kind of profile picture projects. We definitely want to move beyond that and do more stuff. So this is a framework that enables anyone to build custom minters. So you can have a one-on-one minter, generative art, even NFTs for liquidity positions. So if you use Uniswap v3, you kind of know what I'm talking about. You can have a name service. You can build non-transferable NFTs, POAPs, all kinds of stuff. And the cool thing is this is all tied into governance. So if you have any kind of parameters, like, for example, token price or whatever, that can be voted on through regular Cosmos governance. Here's kind of a high-level diagram of how it works. Apologies if this is kind of too small to read. But basically, the way it works is that governance would instantiate these minter factories, and then users will be able to, artists will be able to create new minters with the parameters that they want. And then, if someone else comes up and they want to have a different kind of minter with different parameters, they can come and create another one. So this kind of creates like this kind of scalable framework that just plugs into everything else in Stargaze and just works well together. One example of a project that's building a custom minter is Imago. Imago is a generative art minter. So if you've ever used like art blocks on Ethereum or FX Hash on Tezos, it's very similar to those. It's built by one of our Genesis creators, Stuart. And the way it works is that it doesn't save anything on IPFS or anything like that. It generates art in real time. So based on your address, the block height, and a couple other factors, it generates this art. And we're just touching the surface of this. Like, Rust is so powerful and there's so many really cool creative coding frameworks. And I'm really looking forward to when people port some of these creative coding frameworks and make some awesome art in CosmWasm. All right, how to deploy in Stargaze. Now, you guys probably think this is going to be 10 pages long. But no, it's only one slide. It's only 3 steps to deploy in Stargaze. You upload to the testnet. It's a permissionless testnet. Then you write a forum post on Commonwealth with a link to the open source code. Only open source code is allowed on Stargaze. And then you upload the WASM file through governance. And the voting period is only 3 days. And that's it. So, so the reason for this process is because the main reason for this process is Stargaze has 0 gas, right? And because of that, it's easy for anyone to, if it was completely open, anyone can upload a contract that goes in a loop and just does a state bloat attack and just blows up the state of the chain, right? So there has to be some kind of governance that looks over what's uploaded. If you're a developer, there's several incentives to build on top of Stargaze. If you're writing smart contracts, you can earn 10% of all fees that go through it. And if you're building creator tools like Hubble tools and so forth, you can earn a finder's fee. So a finder's fee is kind of like an affiliate fee. So if you're a creator, you have a huge following, you can have your own website where you can have your own little marketplace there. And then if you do matching of asks and bids, you can earn a finder's fee there. Okay. And coming soon, IBC NFT transfers. So this is something we've been kind of started earlier on in the year, but then kind of had to do lots of other stuff in Stargaze, like working on the marketplace and so forth. But we're coming back to this and trying to finish this off. But yeah, this will allow NFTs to flow between any IBC chain. So in this example, I have an example between Stargaze and Juno. Let's say you want to send a bad kid to Juno, right? First, you'll send a send transaction to the SG721 contract with an IBC transfer message that goes to the IBC bridge, and then it transfers that NFT to an escrow contract, and the escrow contract just kind of keeps it locked until the whole transaction is done. So then it sends this new outgoing packet to the IBC handler. Then the relay picks it up normally, as in how IBC works, and then it'll send it off to the IBC handler on the Juno side. That side will also have an IBC bridge contract, and then once it receives it, then it's going to mint it into this kind of IBC collection contract, and then it is going to be sent to the user who wanted it. So that's how it works on the sending, from sending from a source chain to a sync chain. Then let's say you want to send it back, right? It's kind of a similar process. You do another send transaction on the IBC collection contract. Then it talks to the bridge. It transfers it to the bridge. The bridge transfers that to an escrow contract. And then it sends it to the IBC handler, goes to the relayer, goes to Stargaze. And then when it reaches the bridge on Stargaze, it unescrows it from the escrow contract and then transfers it back to the user. Then there's the ACK from the IBC connection that goes all the way back to Juno and says, hey, the process worked. I was able to send the NFT. And then the bridge contract calls burn on the escrow and burns the NFT because you don't need 2 copies of it. So that's kind of how it works for IBC NFT transfers. We hope to have this working in the next several months. And that's it, folks. If you want to learn more about Stargaze, come check us out on Twitter, Discord, everywhere else. And if you want to get a POAP to prove that you were here, you can scan this QR code and get a POAP NFT, this beautiful little NFT you see over here. All right, folks, thank you.
Hello? Hello? Okay, awesome. Hello, everybody. Good to see you all here. Yeah? So, thank you very much for being here. I'm very amazed. I was here till late last night. Late last night, seeing everyone here and mentoring many of your teams. I have to leave before the final judge presentation because I'm doing a meetup for HackATOM, another part of Gangnam right now. So I'm unable to stay there. But I just want to say a few words before I leave. So thank you for the space to this. I was very impressed to see so many teams picking up both Rust and HackATOM and IBC in one hackathon. I've seen so many people starting instead of their first time writing HackATOM contract, trying out IBC after my presentation. And yeah, it's been amazing to see what's produced. So I've seen some stuff doesn't even make the judges, but I've seen 2 people that were just learning HackATOM write simple IBC protocols last night in 24 hours. So that's, yeah, I just want to give a thanks. These weren't even as a product, but they were just technical research, and that's awesome to see that being possible. So yeah, lots of respect to those 2 developers. And I'll say last night I'm sitting there with Jake, and we decided to, he started making interchain queries. So he wrote interchain queries in like 3 hours, inspired me to write a new IBC osmosis price oracle. So, I mean, yeah, we're like experienced HackATOM devs, and we just knocked this out in a few hours. So it's really amazing to see that. Amazing to see devs with no HackATOM experience writing IBC protocols. And I thought it was really, really amazing to see all the work here. Thank you all for your time. Thank you for your participation. And yeah, looking forward to seeing more of this out here and just really grow. So thank you all. And now I believe Dimi will be speaking. Yeah? Okay, so thank you for the time, Dimi.
Mic live here? Okay. Hello, everybody. I'm Dean Tribble. I was introduced a couple days ago to many of you as a judge, though I did kind of abbreviate, so I'll give a little more background. I worked on the first production smart contract back in 1989 and have been doing large-scale distributed systems and payments instruments for literally decades, along with several of my co-founders. And so we've been working in this space for a very long time. And I wanted to provide a tiny bit of background, and then I'm going to dive into IST. So the important thing that, with respect to a lot of what you're building is, what is a smart contract? We're getting a little echo in case that. A smart contract is software that's enforcing the terms of a contract-like arrangement, generally among third parties, right? So it's not just autonomous software, it's not software running on a blockchain. The concept of smart contracts predates blockchain, and it's about software enabling cooperation, generally among strangers, I mean, and among friends as well, but enabling more richer cooperation across the network. And so, you know, eBay, PayPal, Venmo, Airbnb, Uber, Lyft, all of those were $1 trillion market cap worth of smart contracts, and then blockchain comes along and enables us to make all of that work in a much more permissionless, much more high integrity execution context. So I just wanted to get that out there so that, whether it's Bitcoin or the software that you're making, it's software to enable and enforce terms of cooperation between multiple parties. And that is a new and novel way that software and computers support human interaction and cooperation. Okay, so Agoric is, as I mentioned before, a foundation to enable building those in JavaScript so that the 15 million developers out there that know JavaScript, and whether they're working in fintech or games or band sites or what have you, they too will be able to build smart contracts that can interoperate with all the stuff that is in Cosmos and the rest of the cryptoverse. And so we're building a framework to make that easy, to make it easy the way those large numbers of programmers are used to being able to rapidly put together software. And we see that we've already got some tools for rapid software development that you all have been using this weekend. This is for the next generation and for the next layer of developers out there. Okay. So what I'm going to talk about mostly, though, is the first use case, if you will, the first set of smart contracts that are building on Agoric. Agoric will be rolling out with permissionless smart contracts in JavaScript, but we'll start by rolling out the ones that we've been building to enable an economy running in this environment that all these programmers will be able to access, and that's a stable token for the interchain ecosystem. This is, stablecoin, dollar peg parity thing. What is it? Right? So it is a over-collateralized stablecoin like MakerDAO, not an algorithmic stable token like ones that are no longer available to you in the Cosmos ecosystem. And so it is thus strongly backed by crypto collateral available over IBC. That's one of the unique things about the Cosmos environment is there's collateral on other chains. We'll be able to bring it over, use it as the collateral that backs a stable token that's minted against it. And we'll talk more about that. So it's native to the interchain, which means it's usable in this $10 billion plus connected ecosystem of all the chains that already are running and all the ones that you all are going to launch in the future. And because it's built in Agoric, and what Agoric is built for is it's extensible and evolvable so it can keep up with the changing dynamics of the market and the changing opportunities to provide higher solvency, higher assurance, lower capitalization, and so forth. So, okay. And, before I go very far into it, why do we care? One of the things that's really important about stable tokens is they enable commerce, right? The ecosystems that we see in many places, originally Ethereum, where you had assets and you could trade them, but it was a lot like barter, right? You had to think about each of these assets and how are they valued with respect to each other, and it was very complicated to determine and arrange for interesting economic activity between each other. You could do simple swaps, but doing long-term asset trades or mortgages or lending against these things, they didn't have the smooth ability to price all of these different contracts because they were in tokens that were unrelated to each other. And when stable tokens came out, when DAI came out, and when USDC came out, all of these things that were dollar pegged, now suddenly you could do the same thing the worldwide economy did ages ago and move from a barter economy to a currency economy. And it makes it work much more smoothly, and it is a critical element that led to DeFi Summer, that led to the last round of growth of cryptographic activity, or crypto economy activity. So we need the same thing in the interchain world to enable the next round of growth of cross-chain economics, of cross-chain finance, and of cross-chain applications that are all in terms of something of value in terms of money, whether it's trading NFTs or buying tickets or any of those kinds of things. You got to have a currency. You got to have a currency to act as the grease to make that economy work. Okay, so IST is built using the framework of Agoric Yeah, and so it comprises several smart contracts or components of smart contracts that all work together and plug together. So the list is here. The Vault system is a MakerDAO-like CDP, and I'll talk a little bit more about that. There are contracts for doing liquidation that are reusable. There's a native AMM on the platform. There's a parity stability module, so you can take a existing reference coin like USDC and trade it into IST. There's the reserve for providing a backing reserve to cover shortfalls, and finally there's some integration for the Agoric chain itself, and we'll talk some about each of those. Okay, so vaults. This is where the core value, most of the IST will be minted for the initial deployment of the system, and this is like the vaults from MakerDAO. Where you bring a collateral, you bring a bunch of ATOM, typically, is what we expect, but you bring collateral over, you lock it up, so you lock up $200 worth of collateral, and you mint $100 worth of IST against it. And the value of the collateral will go up and down as the market changes, but as long as it's more than $100, the IST system, the vault system, is solvent. Once the collateral value starts falling, where these are volatile assets, that happens. Once it falls below a threshold called the liquidation threshold, at that point the system gets to automatically sell it. It gets to liquidate it to recover funds to pay for the IST that you minted against it, the IST that some people would view it as borrowed against it, right? And so that means that now, and that IST gets paid back and burned, and so now everything's square. The system is solvent. You add collateral, and this works. One of the ways I characterize the US dollar is it is a collateral-backed stablecoin where the assets are primarily real estate. They have some value. I get a $200,000 house. I borrow $100,000 against it. The house values go up and down. If it falls, the bank takes the house and sells it. Well, no one's living inside of my ATOM deposit, so I don't have to worry about those kinds of things. But the mechanic is well established, not just on blockchain, but historically in large-scale economies. And that's why even with this recent downturn, once all the mechanisms are working, all of these, these CDP-style stablecoins, they work just fine, right? MakerDAO, Celo, all these others, right? Okay. So the key thing is because of IBC, we get to use Cosmos assets as collateral. So this is why it's called the inter-stable token, IST. It's because it's not just a stable token for us. It's really a stable token to be able to be used across a wide variety of chains that are all connected with IBC. So some of the key elements is for each of these collateral types, whether it's ATOM, which has got a long history and a good view of how volatile it is, or something that's much more recent like Juno, or some new zone that isn't out yet, all of those can potentially participate depending on what the community chooses, but the parameters, the economic parameters will be different based on the volatility of those assets, right? Real estate doesn't go up and down that fast, so if you had tokenized real estate, that'd be great, right? ATOM goes up and down depending on the market. Other assets, USDC doesn't go up and down very much at all, and so depending on all these different assets, they will get different required collateralization ratios, different fees, different liquidation thresholds, all those kinds of things. And a particular control that allows us to include all these very different collateral types is debt limits. Right, so ATOM, we know there's billions of dollars there. We know that there's a lot of people. There's a long-term value there. There's a community in which you can easily sell it, and so that can have a very high debt limit. But some token that everyone is really interested in, but is relatively new on the scene, that'll require more collateralization. And the amount that the overall system is willing to mint as an ecosystem in order to make sure that IST is good and solid for everybody might be more limited than what you'd be willing to mint, allow people to mint IST against for something like ATOM, right? And that allows us to have, new assets come in, grow in robustness, grow in economic health, and become more and more of an underpinning of the stable token that we're using across the interchain ecosystem. Okay. So AMM, so another crucial contract in here is an AMM. This includes a fairly simple AMM, but where the base, it's a Uniswap v1 style, where it's every asset against a base token type, but where the token type here is IST. And the role of this AMM is not to compete with osmosis or try to grab market share or what have you. The role of this AMM is to be where a bunch of liquidity exists for liquidations of the vaults, right? Now, it will also be useful and valuable for local economy once there's local economy growing on the Agoric platform, but as part of the IST system, what happens is when vaults get liquidated, instead of having to post an external auction like many of the existing CDP-style stablecoins and have people off-chain bid for the assets. You know, if ATOM value fell below a threshold or someone was borrowing as much as they possibly could and then ATOM value fell by 1 penny, suddenly they're going to get liquidated because they were riding the edge of that market value, right? So when that happens, instead of the system going, okay, I've got some ATOM to sell. ATOM to sell, right? Instead, the liquidation mechanism can take those atoms, turn around and automatically sell them asynchronously using our contract infrastructure, automatically sell them on the local AMM. And then liquidity providers that want to come in and be in a position to get cheap ATOM because it's getting liquidated and so it's going to be sold at a discount, they can come in and just be prepared to buy it off the AMM. And they can have automated mechanisms and contracts to be able to buy it off the local AMM. And what that means is the vault system can ensure its solvency quickly, right, in an automated fashion without waiting for off-chain channels that might get compromised along the way. So it makes it for a very efficient and robust liquidation mechanism. Okay? Then the next element of this overall set of contracts that work together is the parity stability module. So we see these systems like MakerDAO, it has the ability to, when it has the ability to take USDC, bring it over, convert to DAI, and it sloshes back and forth depending on whether people are long on assets where they bring ATOM, borrow against it, or mint stable token against it, or whether they're selling it and now people with USDC want to go and pick up the ATOM, right? The mechanics here are, okay, so when liquidation is happening, the fundamental thing that keeps IST with parity to $1 is how efficiently arbitrageurs can come in and buy and sell the assets that underpin the IST value for $1, right? So we've got a price that comes in and says, ATOM is $10 now, and people borrowed it when it was $11. ATOM is $10. I've got people that will now buy up the ATOM that's for sale at a discount. That will then drive the IST price to $1. There's these mechanisms so that as if the IST price strays from $1 to $1.01, people want to buy IST and sell their IST that should be worth $1 to the people that are willing to pay $1.01. And when the price then goes back to $1, they can buy it up and pay off their debt. Right? This is how arbitrageurs help keep the price of IST at near $1. Is that when it goes above $1, they have reason to sell the IST that they have. When it goes below the $1, they buy the IST, and there are incentives there are incentives in the system to encourage people to do that. Providing a mechanism so that they can bring in USDC, convert it to IST in order to participate in that arbitrage makes it very easy for the system to grow quickly, as there are lots of people out there that have USDC in their account. So market makers are in an easy position to come in and help stabilize this token for us, to help participate in the economy of stabilizing IST, so that we can use it across a broad range of economic applications. And I apologize for the confusing description. I'll need to come up with a nice diagram for how that arbitrage mechanism works to help drive stability of the IST stable token. But the fundamental thing is when it goes above $1, people have reason to sell it. When it goes below $1, people have reason to buy it. And having this nice reference USDC asset there makes it very easy to tie into all of the rest of the crypto ecosystem's pricing of ATOM or pricing of Osmo or what have you, because if I can, on one venue, I can take ATOM, sell it for a certain price in USDC, bring it over to the Agoric chain and convert it to IST and buy stuff. All of that helps these different systems over IBC equilibrate to the same price for ATOM on multiple systems, and that lets all of these dollar prices stabilize with respect to each other. So, All right, I dove a little too far into that. I'll go into the second or the third-ish mechanism for getting IST. And these are ways that one gets IST. You bring Atom or Osmo or what have you as collateral, you bring USDC and you get IST, or there is a native element if you're on the Agoric chain where the Agoric staking token is billed, BLD, where people that are supporting and operating this system on which IST runs, those people can get a small amount of IST from their staked build. And this is one of those things where some people look at it and go, wait, is this sketchy? Is this a problem? Is this one of those algorithmic things? Like, no, no, no. There's no mechanism by which this causes new build to be minted, right? There's no mechanism by which this causes unreasonable amounts of IST to be minted. The fundamental thing here of why we do this is we don't want build, which is the staking token for the infrastructure on which this operates. We don't want people to have reason to not stake with it. And we don't want people with staked positions to over collateral, you borrow too much against it and suddenly they get slashed, and now this staked token, this staked build that is helping secure the system is suddenly now at loose ends. That's bad. That means you're competing with your economic value and with the security and stability of the system. So instead, staked build holders, that's the staking token for the Agoric chain, they can borrow a small amount, they can mint a small amount of IST against the build token so that they can use it to pay for fees on chain, or they can use it to buy up liquidations or what have you. But this is by far a small percentage compared to the IST that is minted against the interchain assets that come across. Right? This is where all of the elements, all of the extensible elements as we grow the mechanisms providing IST, they're all controlled by parameters like debt limits to ensure that a certain new asset type or new mechanism can't put the overall safety and security and solvency of the IST stable token at risk. That we can have high assurance that the stable token system is robust while still enabling growing new entrants in the system, new mechanisms, and new facilities to make it easier to get and use IST. And so this is an example of one of those where a small portion of it that is well backed by reserve enables people that are on chain with build to be able to use and participate in IST locally. Okay. So that point about enabling extensibility, we know a lot about stable tokens. We've been working on the overall architecture of this for over a year now because it's critical for the Agoric system. But it's based on ideas that people have been working on in blockchain for longer than that, and outside of blockchain for even longer. But we also know that the world continues to change, and there continues to be interesting innovations that we don't want to lock in something and then be stuck there. We want a system that can evolve in a healthy fashion. And that's sort of a key differentiator of the Agoric platform is it's designed around composable extensibility, adding new components, evolving existing components, controlled by governance and that sort of thing. So as new techniques for high assurance, stable token mechanisms like delta neutral is if you read about that, that's a plausibly very cool way to be able to mint some amount of stablecoin against, for example, liquid staking elements, or over the interchain to DYDX or Say network or injector, or any of these mechanisms that have long-term perpetual options. That allows you to have very capital efficient assets for a stable token, but it requires a rich market in these particular derivatives that don't exist yet, right? That we're not building, that eventually will exist on Agoric, perhaps, if someone builds it. They will certainly exist across the interchain on chains that are even now rolling out or that people are working on to build. As those come in, as they grow in solidity and value and economic depth, being able to integrate them in with an appropriate debt limit so that they can help provide more, better, rich mechanisms for getting IST and being able to enable more interchain commerce. That's a huge value to be able to extend the system that way. And that's a big part of the overall architecture of Agoric. So, delta neutral stable token mechanisms, insurance for liquidation so that you've got an Atom position and Atom falls just enough to make your vault liquidate. You can have insurance that will cover it so you don't end up getting liquidated. AMM, where currently we have a got a few unique features, but a very simple AMM, once it gets enhanced with things like order books, or if some third party out there comes along and here's just a better AMM written in JavaScript that adds these additional features, the system with governance, people can agree, yes, I like that. We all think that will be better. That will make for a better, more stable, richer, more easily tradable stable token. Let's move to that, right? So there's all these mechanisms that are about enabling this system that we're building and we'll be using to improve and evolve into the future. Okay, so an important element that's critical to stablecoin. How does it work, right? People talk about algorithmic stablecoins. Those have these edges where, well, if you get over here, things go to heck in a handbasket, right? And we've seen that happen. The fundamental robustness for a asset-backed CDP-style stable token here, a vault-based stable token, is not that the asset that's backing it is is stable, right? Whether it's Atom or Osmo or whatever it is, or house prices, they can go up and down. It's not that they're not volatile. It's that when the system needs to liquidate a vault, where you had something that was worth 150 and now it's worth 130, and that crosses the threshold, we'd better sell before it falls too far so we can cover the existing debt. When you want to sell that process works efficiently. That process works smoothly. That's the liquidation process. And one of the reasons why, Atom is plausibly, the most important early collateral type is because there's a rich market for Atom. It's available in lots of places. There's a lot of demand for it. Lots of people want it. And so being able to sell it is straightforward, and so that works really well as a collateral type. So liquidation, the elements of it, right? We've got a vault factory that you made the vault. You've got a vault holding, for example, atoms up on the right, right? And then there is an oracle system, which I'll say more about in a minute. There's an oracle system that is reporting prices, aggregated from exchanges, from osmosis, from wherever it is, to come up with what's the current trading price externally in the market for, in this particular case, Atom, right? And in the Agoric infrastructure, that's just another DeFi Lego. Our vault contract just signed up and said, when the price crosses a certain threshold, let me know. It wakes up asynchronously. It's told, hey, the price dropped below a threshold. And so the vault that vault up on the right is handed off to a liquidation contract. And that, a liquidator, right? And the nice thing about the Agoric architecture is that's a separate contract. It's a separate contract. All of these contracts are working with each other asynchronously, so there's no blocking, there's no reentrancy bugs, there's none of that stuff. And what happens is the vault is handed over to liquidation. The liquidation then takes the collateral, sells it either to the local reserve that says, hey, I want this, I want this. If Atom falls below a certain price and is willing to be sold for $8, I'm taking it, right? Just put it in the reserve. We're extending our depth of Atom collateral in the overall reserve in the system. Right? But otherwise, sell it on the AMM locally, right? And that's the mechanism, and the liquidation contract that we have, it doesn't just do that. It actually is looking at the AMM's price versus the Oracle's price, how much it can sell before having a price impact on the local AMM, and is continually monitoring that so that it is rolling out, it is only liquidating a certain amount per block in order to make sure that it's not contributing to a local downward spiral, even though the overall interchain ecosystem is robust and just fine. We don't want to have big dip in price of Atom on Agoric before arbitrageurs have a chance to correct it by taking some Atom from Osmosis or Crescent or whatever, bringing it over, selling it on a local AMM and correcting the price. And so what happens is the liquidator is now trickling it out onto the AMM, and arbitrageurs and contracts are going ahead and correcting it back to the overall market price that's visible outside of the Agoric platform. And that allows lots and lots of liquidation of arbitrageurs to help provide stable price information and enable this overall system to do efficient liquidations. Okay, so that's one of the key mechanisms of shortfall protection, right? Shortfall protection is, we had collateral, we had some debt against that, the value of the collateral fell. You want to sell it before it goes below the amount that you borrowed against it, right? It was worth $200, you borrowed $100 against it, it's now dropped in price. You want to make sure it gets sold before it drops below $100, and if it does so, then the system remains robust and it can handle very large market downturns as long as it's able to liquidate that stuff efficiently. Right? It doesn't matter where the market is, as long as there's, somewhere along the way at some price, people will buy that collateral, and as long as you sell it quick enough, it'll be fine. Right? So the protections there are efficient liquidations and over-collateralization, right? It's not that we go, oh my gosh, what used to be $200 in collateral is now worth $100, we better sell it. It's what used to be $200 in collateral is now worth $120, let's sell it and make sure we can get 100, right? And all the change we'll give back to the owner, but we just need to make sure that we cover the debt that they currently had. That's the over-collateralization protection. And that's informed by the Oracle price and so forth, as we talked about. But if it dropped too fast, or it was sold too slowly, then you might have $100 in debt for collateral that is now worth 80. And so that's what we mean by shortfall, right? That I was able to sell it, but now I'm $20 short. And so that is covered by the reserve. And there's a separate smart contract that has a reserve that will gradually accumulate fees over time. It will accumulate assets over time as it buys things that are at a low price, as managed by an economic committee that I'll talk about in a minute. And that reserve covers any shortfall so that all the rest of the IST that people have borrowed or minted out there remains robust and has parity to $1. Right? And that's sort of the main mechanism by which all of the system can remain robust, even though the value of the market is going up and down. Right? And there's no interesting coupling between the value of build that's securing this platform and the ability to do these liquidations that keep IST as a stable token. And then finally, of course, worst case, the Agoric platform's job is to make sure this stuff works well and to make sure that it stays solvent. And so worst case, the build holders, the stake build holders, the builder DAO, can either contribute or do new issues to make sure that the reserve is full and covering the existing network. Okay, so. Critical to all of that, and critical to liquidation, is the Oracle network, right? Is getting good Oracle prices, and so and again, this is another one of those pluggable things where, from our perspective, oracles are a. Let me see, I've got like 2 more minutes, I think. Oracles are a critical element of pluggable DeFi infrastructure, right? From my, in JavaScript, I can just say, grab an oracle, when the price of this thing crosses 50, run this JavaScript function, right? It's just a DeFi component, right? So here, but what's backing it up? Where does that information come from? So some of the node operators for Chainlink, they stepped up to build an independent Oracle network for the Agoric platform, where these are people who have been doing it before. They've done it in several infrastructures. They understand what's involved in being able to robustly and continuously provide high quality price information. And so they send price quotes in. There's again, a JavaScript smart contract that aggregates those on a regular basis and provides that price information as a service within the Agoric contract infrastructure. And then, the vault contract says, what's the liquidation price of the most at risk vault? I'm going to wait for the price to cross that threshold. When that happens, I'm going to liquidate some contracts. Right? Okay, so that Oracle network is built by those Chainlink node operators using the large-scale Chainlink architecture that is behind many high-quality DeFi applications out there, and we use that for the pricing for our liquidation. Right? Now, what's important is, again, because the system is extensible, which Oracle operator and infrastructure is used is straightforward and is something that can evolve over time. Also, since this is a service that's just available in the JavaScript framework, being able to remote it across IBC to other chains also is going to be straightforward. So all of these little services each are these individual reusable components that all come together to provide this useful economic service, but they can be reused for other applications as well. So then the last thing I'll talk about mechanically is, how does this all operate? What makes it work, right? So the Agoric system, currently it's got new issuance of build and the staking token in sort of the typical Cosmos style, but the fundamental architecture is to have all of the rewards for validators and all the rewards for delegators come from the fees driving the IST economy, so that they're on the hook to make sure it stays solvent and they get rewarded for the operation and growth of that. And so that means for each of those contracts, for the AMM, there's a trading fee of 5 basis points, which is fairly typical. Build Boost has a fee. The Parity Stability Module has a very small fee because you're going from dollar to dollar valued assets. And then Vault Factory charges interest for the IST that you mint against locked up tokens. And, and those fees, some of them go to the IST reward pool, but when it's past a certain amount, right, that's sort of rate limited. When it's past a certain amount, a fraction of it goes into the reserve. So as IST economic activity grows, the reserve to protect its solvency and protect its robustness grows, so that we stay with a stable system for however, in a solvent system, for however much the use of IST grows across the interchain ecosystem. So very exciting. That's a key element is you really want to make sure that there's lots of people that are interested in making sure that shortfalls do not happen, and mostly that's done around very efficient liquidations. But in order to, we can go into more detail about that. Okay, all of this is managed by governance, of course. There are 2 levels of governance. There's the day-to-day detailed, is it 160% liquidation threshold or 180% liquidation threshold? Is the interest, 1%, 2%, 0.5%, what is it, right? Those are administered by an economic committee that is effectively elected by the build stakers, by the builder DAO. So the economic committee controls debt limits to make sure that new things can come in, but they can't put the system at risk. It controls all of these interest rates and fee rates. And it can propose changes like, this delta neutral thing is really working. It would work this way. Here's what its debt limit would be. You should consider adding that to the sources of IST. And then it's up to the higher level builder DAO, the vote of the overall agoric chain, to elect the economic committee, decide on those improvements, add new collateral types. Do we want to add Osmo? Do we want to add Juno? When do we add Evmos? All those kinds of things, right? Approve upgrades, approve code changes, all those kinds of stuff, that are critical to the actual operation. So changes in software, they're not handled by a random, not a random committee, but a committee of economic experts. They're handled by the operators of the system. Okay? So 2 levels of governance, and one of the key functions of the builder DAO is to elect that economic committee, and we're expecting a governance vote in the near future as we're heading towards launch of what are the exact responsibilities of the economic committee, and then and who are the initial members. And one of the important things is it's not that the economic committee is flipping a coin and going, I think it's 180% this week. What we're actually doing is we're working with Gauntlet. If you're familiar with Tarun Chitra's group, they do iterative economic simulation based on current market data, current levels of collateral and all the different exchanges and that sort of thing, in order to figure out, in order to provide a set of parameters for all of these debts and interests and so forth to inform the, to provide and balance, solvency risk with collateralization ratios and economic efficiency. And so having a set of experts that are continually doing this analysis, they provide, here's a model for this week, and then the economic committee goes, yep, nothing looks wrong there, we'll go ahead and approve it, and that will slightly adjust the changes on chain. So we've got this very responsible processes around the economic administration of the system, because it is a currency, right? It is a thing that you want lots and lots of projects to be able to rely on and know that the decentralized operation has a nice, strong trail of assurance of correct parameterization and control. Okay, so wrapping up here, so how can you get involved? Depends where you are, right? If you're a developer, new front ends, right? We've got initial front ends, but that's something that you're all experts at. You can do better or more targeted front ends for getting IST, getting it from wallets, managing vaults, automating the process of vault management, all those kinds of things. I won't talk about MEV stuff, though we can talk about that elsewhere. But expanding these things, right? We talked about, there's a PSM and there's a liquidation thing. You may have a better liquidation algorithm that is more efficient, more economically sound, or simply liquidates over IBC over to liquidate directly onto Osmosis or Crescent, right? So there's definitely, this is a community effort, and we expect to integrate well with lots of other chains. This is a place to be able to go build it. if you're a capital provider, a market maker, an arbitrageur, get prepared for those liquidations. Set up to understand when the market is changing such that you're in a position to provide liquidity into those liquidations and capture some of that value. For if you're bringing up a new chain or a bridge, right, basically, arrange your system to use IST. If you're going to have a perpetual option system, it's got to reduce into some stable token. You don't want to build another one. What you want to do is use something that everyone else is going to use. So setting up to be able to use IST for that easily is going to be of value. If you're running stable swaps, make sure that this is one of the things available, so it's very easy for people to bring, USDC over Axelar and USDC over Thorchain and USDC over wherever it is, which are all these different denoms and IBC, bring them over, convert them through the PSM to one IST and use it on a bunch of different platforms, right? Whatever that mechanism is, there's places where you can extract value here while providing good service and useful service to the rest of the ecosystem. And finally, if you're a fintech developer building some interesting new DeFi, there's lots of ways that can help integrate in and not only provide value for yourself, but provide value to the people that are using IST or that want to underwrite IST, because you can provide more economically efficient or additional robust mechanisms for people to be able to participate in this ecosystem. So please join the community, come to the Twitter Spaces. We endorse, adopt the mean of IST, right? IST, right? And come to Cosmoverse, where we will have many new things in additional detail, and have gotten through. We've already gotten through security audits. We're going through economic stress tests now. We'll have releases that are heading towards launch in that time frame, and we're very excited for you to then come and talk about integration with all these other projects that are being built. So. Thank you all very much for your time, and you're building. You've seen a lot of what there is existing now in your current stuff. This is something that you'll be building for and being able to use in the future and being able to extend in the future. So we really look forward to all of you developers coming on board. So thank you much.
Hello, hello. All right, welcome everybody, and congratulations for making it to the very last moment of the HackATOM. Woo! You're all here making history. We're in the very second in-person one in HackATOM Seoul, so this is awesome seeing everybody here. Our prizes have gotten incrementally bigger over time, which is good for you if you win. So, my name is Chango Unchained, and I am an early contributor of Cosmos Network, and right now I'm an advisor to Osmosis, and I myself run a validator called Interchain FM Stake. So don't stake with any of them, stake with my validator, obviously, 100% uptime. Anyway, let's go with some intros from this side all the way to over there. Also, you want to support the women in blockchain, by the way. I'm just kidding. None of the men laugh. Go ahead.
Hey everyone, my name is David. I work on partnerships and investments at Cosmos Station. For those of you who haven't heard of us, we're a validator node operator across 40 to 50 different protocols. We also run end user applications like MintScan and Cosmos Station mobile wallet extension. And we support the networks that we run a validator for with these end user applications. And please stake with us.
Okay, hello. My name is Hyungkyu at DSRV, and we are also supporting various Cosmos blockchains and also other blockchains. And so we are also providing many development tools for developers, and also we are welcome everybody to join us. So please contact us if you are interested. Thank you.
Hi, I'm June Park. I'm the founder and CEO of ProValidator. As many of you know, ProValidator, we're validating across several networks, most of the major networks across the Cosmos ecosystem. Currently, we're more focusing on the validator side, but we look forward to expand in other areas such as providing community tools and also like analytics tools to the community. And yeah, I look forward to communicating more with the overall Korea community.
Hi everybody, I'm Teddy. I'm a protocol specialist at Stakefish, and Stakefish likes to focus on governance, and that's what I do. And we validate a variety of Cosmos chains.
Hi everyone, I'm Alex. I work in business development and ventures at Chorus One. We're a multi-chain validator operating across 30 plus networks. Right now we're probably a team of around 40 people, mostly sort of engineers and researchers. And earlier this year we announced our venture fund to support some projects that we are particularly excited about. So anybody here wants to chat, give me a shout after this, and yeah, excited to talk.
All right, thank you to all the validators. And since this is such a, the Cosmos ecosystem is growing exponentially, and all of you are part of the community, so let's get to know you guys. How many of you guys also run validators or have run a validating node? Can you translate, Erica?
발리데이터 돌려보신 분 혹시 계실까요? 손 좀 들어주시겠어요? 혹시? 손?
How many of you know what sentry nodes are?
센트리 노드가 뭔지 아시는 분 손?
All right, quite a bit of you. How many of you want to run a validator in the future?
돌리시고 싶으신 분, 검증인 하시고 싶으신 분 손?
Okay, very cool. So this entire panel is going to be about how to run a validator, how to contribute to the Interchain ecosystem if you aren't already. So yeah, let's talk to you guys. How have you guys gotten started? How is it to bootstrap your validator? Was it difficult, easy? What's the barrier to entry like? Costs? I mean, we just start like this in this direction.
Yeah, so I feel like a lot of the validators may have different strategies when they approach how to onboard delegators to their validator node. For us, it was to provide infrastructure like end user applications like the MintScan Explorer that I just talked about, and a mobile wallet, And bootstrapping your validator with delegators is a difficult task. Not only do you have to focus on providing value like I just explained, you also have to communicate with your delegators and figure out what types of services they need. And also, yeah, do a lot of due diligence on the new networks that you're onboarding as a validator node.
For me, yeah, we started validating the blockchains because we want to know the protocol much more. So if you want to know some protocols, then I suggest to run a node. You can start from the float, and you can next time you can start a validator node. And I think that running a validator node requires some professional skills, but at first, I think that currently many blockchains provide an easy way to start a validator node, and so I think that most of developers can, or even non-developers can start a validator node. The problem is that if there is something happen unexpected, then I think you need some more skills and some expertise to run a node. So I think that running a node itself is not a hard problem, but it is the problem is that how to solve the problem if there is some problem occurs. So that's my opinion, and yeah.
I think the quintessential thing of running a validator is building a community. I started validating at Lunamint, and in the beginning, what we tried to do was we tried to really expand the Korean community, educate the community so that more people could engage in the entire ecosystem. Likewise, I think the technical contributions, the technical prowess is also very important, but in the end, it's really about expanding the pie, building a community, and educating those community to become potential delegators. So if there's anybody who really wants to start a validator, I think the most important thing is building a vibrant community, regardless of the region. So yeah.
Yeah, so at Stakefish, we think about the key aspect of getting people to delegate to us as a piecemeal combination of strategies. One of the strategies that I guess I think about a lot is just competence and governance, and that is something that just requires man hours, where people are thinking about proposals, building relationships, talking with people in the ecosystem, and then broadcasting what you're doing. And hopefully people will see that if they delegate to a validator that's participating in governance and trying to govern the chain well, that's good for their token's value.
Yeah, so I mean, Chorus has been around since 2017, and I think it's important to point out that, from a technical perspective, things are going to change quite a lot, particularly in the Cosmos ecosystem, as we're seeing things like interchain security. So maybe from a technical perspective, we're not best advised to talk about how to get something going from the ground up. However, I do think some of the common themes that we've mentioned here, like community development and governance, these are all really consistent, important themes that you should probably be aware of. And also, I guess, just the responsibility that you have as a validator, it shouldn't be taken lightly. You are supporting the network, and I think that should be something that you should focus on and take seriously.
Right. The thing in Cosmos Proof of Stake is that it's all reputation based, and so as you can tell, each one of us has had different entry points into the ecosystem before we started validating, and so it's similar to here, right? If you're participating in this hackathon, you kind of have formulated a team here. If you win, you get your name out there, and then for branding purposes, you could say, okay, well, my team won, and this is the same name for my validator, and you're going to start building a reputation from there. So you could bootstrap in basically any way that you want, as long as there's a will, there's a way. I mean, I know most of the people here are developers, but if you're not a developer like myself, but you have something else to bring to the table and would partner with somebody who has the right skills to run a validator, you could do that as well. So it's just, you get started in any way you want. That's just the point that I'm trying to make.
I would just echo that. I think I've met two kinds of validators. You've got the people who are just very good at marketing, and they've just kind of accidentally fallen into validation, they do very well because they're good at the marketing side of things.
Right.
And then there are validators who are excellent from a technical perspective, but maybe don't have the marketing expertise. There's a happy medium in there somewhere, right?
Right, exactly. And so that, the idea with my podcast is it's like a loss leader, but it's sort of like the top of the funnel marketing channel, and then you get them down to validation. And the same thing with Cosmos Station is your loss leader is the wallet. You guys don't make any revenue, but because you guys have built such goodwill in the community, people are willing to delegate to you. And because it's your interface, you put Cosmos Station Validator as like the top one, and everyone just delegates to it by default. So all that's very interesting. As long as you're very creative with your business process, then you could do anything. All right, that being said, what are the risks and costs of running a validator? Are there any risks?
From there. Yeah.
Okay, I'll go. Should I go? Okay. Yeah, I mean, right now the markets aren't in the best conditions, so times like these could be, one of the risks that a validator operator could face. Revenue could decrease significantly in events like this, so it's always important to sort of balance your balance sheet well and prepare for incidents like this. And also another risk would be, it's associated with the first thing I talked about. It's really difficult for a validator to stop operating a node for a network that we don't see any reason in continuing to participate in. So once we put up a validator node for a network, it's almost impossible for us to put that down. And you could do that, but it's not a good look for you, reputation-wise. So there's that risk as well. And yeah, I think I'll pass the mic.
Okay, I also agree with him, and the participating is very hard to, and actually we did not participate in any protocols because we created the protocols to participate, because we also agree with him that it's very hard to participating. And I think that I want talking about some technical aspects of risk, and that in the most of you know that there is a double slashing, and the downtime slashing is provided by Cosmos-based blockchains. And yeah, that when we think of the double slashing and downtime slashing, most of the team thinks that they can prevent it from being slashed, but actually there can be some possibility that double slashing can be happened if there is some human mistakes or some kind of some hackers intruded and get the key and launch on another node, so that it can be happen. So it's very hard to prevent it from being slashed at all. So yeah, we always have to make it can be happen, so that we have to prevent it from being slashed. So that's as a technical aspect. That's the only point we are concerning now, and the other aspects are some kind of financial things and economic things. Then for that, I think that the market cannot be predicted by anybody. So because I'm a CTO at the DSRV, so I'm concerning the technical aspects, and for the marketing, I think the others can talk about that risk more. Thank you.
I think there's two risks when it comes to running a validator. One risk is about the operational risk. So as you know, validator is a business, so it needs to have revenue, and then you need to cover the costs. There's server costs. There's like employees. So if the market condition changes to a more bearish environment, as a business, it becomes more hard to secure runway, secure the balance sheet. So I think that's one risk of running a validator. The second one is the technical side. So as David and CTO mentioned, there's like double signing and a lot of risks that is related to running a validator. And sometimes, validators become victim of bugs that cannot be predictable. So if there's a specific bug in a code that we run, even though it was not intentional, we might end up in a situation where we face like double slashing, double signing. And in that situation, we need to persuade, we need to explain the situation to our delegators, and also cover the losses that they faced. So yeah, I think we can summarize. There's like operational business risk, a logistical risk, and then also a technical risk.
So I don't think of running a validator as being a particularly risky area of business, but I would mention one more risk, which is undelegation risk. If you have a big delegator who dominates your delegation, then that actually is a lot of centralization on your revenue. So you want to keep that delegator happy, but ideally, you wouldn't have that kind of centralized delegation.
Yeah, without kind of covering what these guys have already talked about, I'd probably add some of the softer stuff as well. Like, for instance, if you get to a position where you can scale and you need to have employees and people in place, I guess just remain mindful of the fact that you're securing a lot of value, and you need to have trustworthy employees, right? And it needs to be a very trustworthy environment. And maybe on top of that as well, I'd add maybe there's some regulatory nuance, which is probably quite important around custodians and ownership of tokens, and that's an ever-evolving area, so definitely something to remain mindful of.
All right, well, thank you guys for your insights. So in terms of P&L, and I know each of us is running validators for various different Cosmos SDK chains, which chains are the most profitable that you could tell. Some of you guys also aren't exclusively running validators for the Cosmos ecosystem, right? So yeah, we could talk about the ones that you guys are validating for outside of it as well, if they're more profitable, and why.
For some time, Chihuahua was actually pretty profitable, and but it's not profitable anymore. Like I said before, it's always important that you get significant, I guess, like some runway in order for you to like keep operating your node. But right now, I think the most profitable would be Cosmos or Osmosis. I'm not sure if I have the exact numbers in my head right now, but yeah, that's what I think is most profitable right now.
Yeah, as mentioned before that I don't trying to break the markets, and so someone told me that validator is basically born to be a long position in the market. So yeah, so that's why we are experiencing hard times during the last bear market, and I think that the validator is a role to secure the network. So yeah, I think I don't want to take some kind of proactive approaches to the market. So yeah, just passive and want to provide some secure and stable networks. That's my opinion. Yeah.
Regarding profitability, reputational-wise, I think Cosmos Hub is the most profitable chain that we operate, since it's not the canonical chain, but it's the most valued chain within the Cosmos ecosystem. So yeah, strategically, I think Cosmos Hub for us it's most profitable reputation-wise. In terms of financially profitable, currently I don't have the exact numbers, but recently I think Evmos was very profitable. It was pretty lucrative. And also Osmosis was very helpful for the balance sheet. So yeah.
Yeah, I think I remember seeing Osmosis at the top of our charts.
All right. So, as the community, maybe we could ask you guys questions and see what you guys want out of your selected validators and what you want to see out of people, like what sorts of improvements or feedback you guys have. Yeah, hey, can I get a translator? Oh, yeah, okay. Can you?
Wait, can you?
Yeah, well, I just want to poll the audience to see what you guys actually want out of your validators.
Question over here.
Okay. Let me translate this real quick and then I'll take your question. Sorry. 저희뿐만 아니라 이제 검증인들한테서 원하시는 어떤 모습들이나 그런 서비스들이나 뭐 그런 것들이 있는지 질문을 하시네요. Hey, could you please, yeah.
So you talked a bit about the operational risk due to slashing, and I was wondering if you had thought of any changes that could be made to the way slashing works. As far as I'm aware, the way it works currently is partially due to like historical reasons and simplicity. There's a lot of room for change, I believe. Have you thought about that? Have you lobbied for changes? Have you talked with developers of the SDK of how to get changes in slashing?
I mean, I don't necessarily see slashing conditions as some sort of like legacy antiquated thing. It's there for a reason, for security. And so for people who are not happy about the 14-day unbonding period, you know, if they just want liquid assets, there's plenty of solutions out there that people are building, like liquid staking or like interfluid staking from Osmosis, to solve that user issue without compromising the underlying security of a proof of stake chain. Because the 14-day unbonding period is there to mitigate the longest chain attack, which is, do you know the long range attack, sorry. Yeah.
Yeah, okay, thanks. I mean, I think the way it works now definitely achieves the goal, but there may be other ways to achieve the same goal without such large risk for you guys, for the validators. So I'm just wondering if alternatives were considered.
Yeah.
Thanks.
It's
Thank
pretty
you.
like, yeah, the tenement way of doing slashing is the gold standard for proof of stake security. Yeah. And it remains that way.
Yeah, okay, thanks.
질문 혹시 있으신 분들? Any other questions? Oh.
I had a question for the panelists. So across different Cosmos chains, there's a lot of community funds that gets accrued, and not a lot of them are being actually deployed or being used at all. I was curious if the validators could chime in on like what they think should happen with the community funds. Like, should they just sit there, or should we start like deploying them? I'm just curious about each of the validators' thoughts around that fund.
I feel like if there's a lot, like if there's enough community funds sitting there, they should be deployed into teams that are building meaningful, things for the ecosystem. For example, like infrastructure services, like API services, or even end user apps like wallets. It's always good to have a lot of wallet options. So I feel like if there are teams that are building, like I guess front ends as well for the chain, it would be nice to deploy those funds in order to fund the development of things like that.
Yeah, I agree. I think more kind of like social impact or sort of environment, ecosystem support would be a great way to use those funds, particularly if those funds are increasing, which I suspect they will do over the next sort of few months, years with interchain security. I guess it's just, it's how do you decide on how to allocate? That's the golden question, right? So, yeah, I don't know, but interesting area.
I think it depends on the chain. I mean, if the chain is oriented around AMMs, for example, Osmosis, then they're going to try to build out that ecosystem of functionality. But if there's another chain that focuses on, I don't know, DogDAO, then it's going to have a completely different agenda for spending money. But yeah, I think it should probably think of it a lot more like, I guess depending on the chain, kind of like a business where make sure you get return for your money. And don't necessarily walk around like just trying to spend it, letting it burn a hole in your pocket. Like you can wait and spend it when there's a good opportunity.
Yeah, I also agree with all the other folks. I think it's really subject to governance, so it's like an open decision, and it's also subject to a specific chain. So I don't think there is like a de facto one standard. It really depends. It's very subjective. It's open, and yeah, I think this is an issue that should be discussed through the governance too.
Yeah, basically I agree with the various opinions already mentioned, and basically I think the blockchain is about the decentralization and permissionless. So I think that the decision can be made by anybody with any other reasons, depending on their position. So yeah, I think there is no answer for the question. So yeah, thank you.
All right.
Hello. My question is about acquiring scalability in terms of participating in governance. Our team also runs validators on multiple Cosmos app chains, but it's quite significantly lower than the companies that you guys represent. And if you participate in like 20 plus or 30 plus, 40 plus like ecosystems, there would be like a lot of like governance proposals that you have to like go through and like do the votes. How do you kind of manage the resources internally, and how do you scale when you grow into 10 plus, 20 plus ecosystem validator participant?
Okay. Yeah, actually that's the problem we are supporting now, because the one problem is that not the number of the protocols, but there are some kind of conflict of interest now between chains and between protocols and between DApps. So yeah, actually we are trying to solve it by maintaining some research teams inside and many business aspects. So we have to consider business aspects and the technical aspects all together, and it's very complicated. So yeah, actually we do not have a solution yet, and we are also trying to solve the problem. So thank you for the question, and I think others can add some.
First of all, we try to utilize the tools that are provided in the broad ecosystem. So a lot of wallet providers and also MintScan, there's like good dashboards where you can see aggregated governance proposals across several chains. But when it comes to actually voting specific governance proposals, I think there's like a layer of steps that we go through. So first, we internally make our own decision, but we don't, vote for the governance just right away. We try to reach out to very vocal community members and try to listen to what they think about. And listening to them and communicating them, we come back to our internal team and then decide whether we're gonna stick to our previous vote or gonna change to another vote. So I think the governance process, how you vote, that's different among validators. But yeah, I think, the most important thing is always trying to listen to the community when you decide to vote. So yeah.
Oh, I would add to that as well, which is, yeah, the super straightforward way of scaling it up is by polling your community. So that's what we do too, and this was inspired by what Orbital Apes does as well, which is they just maintain a community of people on Telegram and Discord, and then every time there's a governance vote, they poll the community, their delegators, and then we basically say, okay, we're just going to take this straightforward majority vote, yes or no, and do that for every single chain that you support. Sorry, go ahead.
Yeah, I totally agree with that. There's not tooling right now to verify that they're delegators, but there should be when they're doing polls. I think this is a really complicated problem. Like, there's going to be many different angles through which I believe it'll be solved over time. One of the angles is that I think that as a small validator, you can, in essence, redelegate your vote to a bigger validator that has the resources to think about smaller chains that may not be on your radar. And then once you get to a sufficient enough size and you have the resources to employ a protocol specialist, then you can vote on your own. Another, I think, angle that will lead towards a solution is that I think chains have a lot of work to do when it comes to delegating decision-making to sub-DAOs and to, I guess, more sophisticated government structures, so that you can have panels of experts that are appointed or just better, systems so that there's, money that can pay people to think about things, and it's not just kind of like icing on top of the cake.
Yeah, I think before when we talked about risks of being a validator, I think we overlooked the potential ethical risks of being a validator, and this is when you start talking about governance and you're interacting with real people in a community, and the impact of your decision can really affect their lives. We've seen this on multiple occasions with various different chains. And so, I think there's not really a neat or short answer. I think it really boils down to having a team that is willing to work very hard, be immersed within the ecosystem, understand what's going on in that ecosystem, and be willing to work long hours to make sure that you stay on top of the game. And obviously then balancing that across various different networks so that your mission and values as a company is all aligned across the various different networks. So it's not easy. I think you just need a good team.
Yeah, we have an internal governance committee of 5 people, but that's only like a semi-solution, right? And for each governance proposals, there are many different aspects to it. And as a validator, we not only have to represent the delegators, but also have to take into account the health of the network, et cetera, and everything. So it's always there's always a lot of conflict of interest for some governance proposals. So for more pressing proposals, we try to do more active discussions internally and also check what our delegators think and the overall community thinks as well.
Right. The other strategy is that, if you're a validator, if you're a thought leader in any specific ecosystem, but are not necessarily a top validator in terms of delegations, you could educate the community through your vote alone. And so, our validator specifically is very opinionated about what L1s in Cosmos that we validate for, and the reason for that is because we don't want to kind of scale up in terms of overhead with all the governance. If we're not familiar enough with the protocol, then we're not able to make informed decisions. So that's another strategy as well. Okay, do we have any last questions from the audience before the validators sign off?
Hi, so I have a question about governance apathy problems. Obviously, it's like a pretty well-known problem in the crypto space. I think Cosmos ecosystem is a little bit unique in a way that it probably has a bit more participants, active participants, but I guess what kind of best practice have you guys seen that encourages people to actively participate or think about who to delegate to, and then what are things you guys think should exist to also help that process as well?
For one, Cosmos Station Mobile has a notification thing where where we notify our delegators, no, not the delegators, but the users of the current active proposals. So I think maybe tools like that could help a little bit in boosting participation in proposals. We're trying to do something more similar to that on MintScan as well, try to inform people better on the front page, for example, or try to make it more visible so that people can actively look for governance proposals and look in the details, and maybe even provide a place for people to have discussions on governance proposals on MintScan. So that's something that we've been considering, something like that. We're trying to alleviate it with our end user apps.
Yeah, actually, basically, we do not know who delegates to our validators. So yeah, that's the problem. And as he mentioned, that we're trying to let delegator know about the governance by using Twitters or Telegrams or Discords. But basically, it depends on how the community works, I think. And unfortunately, there are a lot of communities for one protocols. It's basically good things because it's decentralized. So yeah, so actually, what we can do is that using the SNS or many channels or some tools, as he mentioned, that we trying to let users pay attention to the governance things, but as you already know, there's too many spam news and announcements from the protocols because there are a lot of participants. So we are trying to create the message about the important governance from other spamming governance proposals. So that's what we are now focusing on and trying to create the proposals which is much more important and important. We try to create the proposals. Yeah, that's what we are doing now.
I think the most effective way to encourage more delegators to participate in governance is really focusing on the message rather than the methodologies. So we have various ways, community communication channels to let the community know that there is a specific governance being voted right now. But I think it's really important to explain to the delegators and the community why this specific governance proposal is important to you. So some governance proposals really affect, the balance of each single delegator. It could be like an airdrop governance. It could be a governance related to slashing mechanisms, minimum commission fees. So if whether that's a validator or a team or a thought leader, if you really focus on explaining why this specific governance proposal could affect you, I think that could be a very effective way to boost governance participants across the ecosystem.
It's a really good question. I think that most people don't care about governance. In the ecosystem. I mean, I know that there's a small section that definitely do, but I think that the question of how to make people care is hard. I think that fundamentally blockchains are these sort of political objects, and we don't think of them that way. We generally think of them as these economic or these technological objects. And I think that conceptual inheritance really limits everybody's ability to get excited about governance because they think of it as being like icing on top of the cake, to use that expression again. So yeah, I mean, to the extent that we can start to rebrand blockchains as being these big governance machines, and explain to people that these things don't run themselves, like they're not autonomous. And they certainly are not in a good state to support increased adoption right now. And there's going to be a lot of work that it takes to get there. Then people will start to figure out that it matters how they vote, and it matters who they stake with, and it's not just about picking up rewards.
I want to just add to that because what you brought up is really interesting. I'm sorry to cut you off. Right, so I don't think that there needs to be such emphasis on every single individual delegator voting on every single thing and caring about every single thing, because at the end of the day, the Cosmos DPoS mechanism is sort of like a representative democracy where you kind of inherit the votes of your validators. And so we see very, very low individual wallets overturning the votes of their validator, but we see very high turnout for validators voting. And so if you're pretty deliberate about who you delegate with, and pay attention occasionally to how they're voting, and how they're thinking, then I think that's as much as you need to do. But that being said, there's Jake Hartnell mentioned a lot that governance tooling is just so early, and if you're a marketer, you shouldn't necessarily need to care or know how to vote for a technical decision, and likewise, if you're a developer, you shouldn't necessarily need to vote on something that's outside of your expertise, like marketing or whatever. So there's just a lot of progress to be made in terms of the granularity of what governance is supposed to address, like selecting a group of people to vote on marketing initiatives, maybe having multiple choice in governance decisions rather than a binary choice, yes, no. Yeah, so anyway, that's a little spiel. Sorry, go ahead.
Yeah, I agree. I think there's a huge education piece needed, generally, not even just on governance. I think you're right. People don't care about governance, generally speaking. But also people, I think, don't even really understand what staking is. You know, there's a huge retail audience who don't really understand what they're doing when they're participating in a network. And so I think, yeah, there's a big education piece needed. From our side, to answer your question directly in terms of what are we doing, we have a really strong research team who focus on Cosmos specifically. And I think going forward, we're planning to put out a lot more content, whether it's a newsletter, whether it's an article. And that does two things. It educates our audience, lets them kind of know what the impact of a potential decision could be. But it also tells them what our stance is, because we're quite vocal about our position. And so if their values don't align with our values for whatever reason, they can decide, to touch on what you said, to go with somebody who else that does. And so I think communication, education, all those kind of fluffy terms are pretty important.
All right, well, thank you everyone for listening in, and thank you to the validators for providing their valuable insights. I think you guys are all here to learn who the winners are. Obviously, the judges have completed deliberation, so let's just wrap up. Thanks, guys.
Thanks for moderating.
Okay, so we're all gathered together with the judges to announce the winners of HackATOM Seoul 2022. 너무 긴 여정 동안 함께해서 너무 감사드리고요. 정말 저는 저 너무 기분이 몽글몽글하고 진짜 너무 자랑스럽습니다. 그래서 thank you so much for all your perseverance and ambition and passion in going through all this journey with us. And I'm so excited to announce the winners for HackATOM Seoul because the grand winner will be joining me on Middle Asia conference as well. So I'm very excited personally. Anyway, should we go around and who wants to take the first grab? Okay, Zaki will go ahead and announce the winner. 이제 위닝 팀들을 소개할 거니까요. 잘 들어주세요.
Hey, I'm Zaki. I will be doing the interoperability prize. So the first prize winner is third prize first. Logical. Is the Empower team. Their project was a sort of a cross-chain trading mechanism for doing like plastic credits of some kind. And then the second prize was Team Blazerbit. They did a sort of multi-chain DEX routing, so you could do like atomic swaps between two different chains, which was very cool. And then the first prize is Team A41. They did a sort of liquid staking thing, but one of the thing that was most novel is they proposed an alternative to stable swap for like trading like things with like a known discounted asset rather than a one-to-one correspondence, which was cool.
Zaki, congratulations. And can the teams come on the stage and we can actually we have some prizes that we want to give out. So can you wait for the next announcement because we do want to get the teams over to the stage and give out the prizes.
All right, come on up.
네, 나와주세요. 아까 방금 말씀하신 팀들. 네, 박수
Empower,
부탁드립니다.
Blazerbit, A41. All right, second prize, Blazerbit. And then for the third prize, Empower. All right, we'll go to the next prize. We're gonna do interchange security and SDK. Okay, so for the next prize, we're gonna announce the Interchain Security Prize. So for this prize, we actually only had one team contending for this prize. So we had the discretion, to give first, second, or third prize place. But we were so excited with what they came up with that we decided to give the first place. So this is for the Node Infra team. So they proposed a modification to the governance module. Yeah, congratulations. Woo! So, okay, they proposed a modification to the governance module, so it would allow votes impacting the consumer chain to be voted on by both a combination of tokens from the provider and the consumer. So, an innovative way of looking at voting design. So, congratulations, guys. Come on up. Awesome. Great.
All right. So now on to the SDK price. At third, we were very impressed by the shoulder lifts. Third prize, OPCT. They built, congratulations. They were building a fitness app that sort of like uses image recognition to see how you're doing, and it's based on an NFT, a dynamic NFT that would go on chain. So congratulations for third prize. On the second prize, we have, I'm hoping I'm pronouncing it right, HackATOM. Yes, congratulations. They built two things actually. They had built an explorer that was actually easily configurable for other Cosmos chains as well. At the same time, they had also built a proxy between Smite and the Cosmos SDK. Smite is a particular interpretation of Tendermint. So congratulations to HackATOM for second prize. Well done. And for first prize for the SDK, we have Team Orange Pulp. Yes, they built an amazing user interface that aggregated wallets from between different blockchains, even a MetaMask wallet integrated as well. NFTs aggregator. It's a really user-friendly approach that we think is very relevant at the moment. So congratulations to Team Orange Pulp for first prize in the SDK. Thank you so much. You can come up front for the photo.
Yeah. 1, 2, 3등 분들 사진 찍으러 나와주시면 감사하겠습니다. Awesome. Next up, I'll be announcing the Osmosis prizes. Oh, yeah. Okay, starting at third prize, we have one winner, and third prize is OPT. Cool. Next up, we have second prize, and the winner of the second prize is Alcohol. Congratulations! Oh, and I forgot to give brief intros. The OPT team created a Oracle module as well as a swap kind of diversifier where you're able to kind of optimize for multiple routes. The algorithm team actually went through and built an actual subgraph that was working, as well as a mechanism to execute trades in a permissionless and non-custodial manner, and basically formulate strategies in Python executed over Osmosis AMM. So yeah, both of those were extremely cool. First prize was extremely impressive. And here, let me just make sure I don't mess anything up here. Yes, cool. Yep, the first prize goes to Emrys Orphans. Emrys Orphans, can you guys come up? Cool. And the Emrys Orphans built a tool where I think it would have been actually extremely useful if it was live today. And we know a lot of the products that you guys are using to build a lot of the tools, such as Kepler, started as a hackathon project. And these guys built an explorer with a thesis of, not an explorer that covers all the block history, but basically the last 100, which is really important when you are developing, testing out code. So yeah, it would have been really valuable. Ethan Fry loved it, and he was like, "Yeah, this would have saved hours of my time." So yeah, congratulations, and we hope to see this live soon. Yeah. Cool. Awesome. Congrats. And then I'm also announcing the Juno prizes on behalf of Ethan, who is currently not here. And just a heads up, we don't have a first prize for Juno because I think there were only 3 projects and the first prize criteria that we set internally wasn't met. So we will have 2 third prizes and 1 second prize. And for first of the 2 third prizes, it's James and Sagyun. Congratulations. James and Sagyun built a virtual AMM using Cosmwasm, where you're basically able to kind of create a virtual AMM that allows you to trade multiple different kinds of derivatives asset with funding built in. And yeah, it was really exciting to see that. So congrats. And the second of the Juno third prize goes to Hallie. And Hallie built a very beautiful front-end DEX aggregator where it shows you the multiple routes that you can take. We loved how it was presented for the user in terms of how the routes were divided. And I think, it was one of those products where rather than abstract, I think it could be a very educational tool to show you how a swap could be divided to give you the best prices. And they built an extremely beautiful interface. So yeah, congratulations. And lastly, for the second prize, goes to Taiki. Oh, Taiki is currently not here, I guess. But Taiki built a Cosmwasm contract that leverages interchain accounts, as well as what was the other thing? Oh, it was a multi-sig interchain account contract wallet where you're essentially able to interact with multiple devices and one chain to kind of control a lot of other accounts in other blockchains using Cosmwasm over IBC, which was extremely novel. But unfortunately, it wasn't to the quality that we expected for a first prize. So yeah, it would be on the second prize. All right, thank you guys. Oh, and lastly, we have a persistence prize, which was hand-selected by Ethan Fry. I will be announcing on behalf of him as well. That also goes to Emrys Orphans. So congrats, guys.
All right. So, all right, getting in place. So for the Evmos track, we had a ton of great submissions. Shout out to the Evmos community pool for sponsoring this prize. All the projects that were submitted stood out in one way or the other, but the three we selected for the prizes stood out on just their technical acumen. In third place is Loredana, with building on top of the work that she presented yesterday. Basically, in 2 days, she managed to build out an interchain object system that allows you to shard data across multiple chains using IBC on EVM, alongside other cool features that she'd previously built, and demonstrated it with basically homebrew tooling. So congratulations, Loredana. Well deserved, well deserved. In second place, we have James Web3 with a tool that solves a relevant business use case for a ton of teams that I've spoken to who've deployed on Evmos, which is basically making airdrops easier and more effective at reaching target audiences. So come up here if you folks are around. Yeah. Airdrops, as we've seen in the Cosmos community, are super important and very relevant. People do love their airdrops, but they don't always fall into the right hands. And so the tool that this team built can certainly help users bootstrap their communities in that way. Welcome. Congratulations. Thank you, folks. Congratulations. Last but not least, for first place, we have the Da Vinci team, who stunned the judges with a very sleek interface. Congrats, folks, congrats. So, these folks built an NFT fractionalization tool that lets you interact with NFTs in brand new ways. I'm super excited with how it'll evolve and utilize maybe interchain NFTs in the future. So, congrats, folks. You deserve it. Take care. Okay, I'm sorry. Cool. Thanks, everyone.
All right, so we got one more prize, which is the main prize, which allows your team to go to Biddle next week and come and talk about your project, right? So there's been a lot of really good stuff being built here, a lot of technically challenging work that's been done in the last couple of days. Oh, what? Sorry? Oh, we got the MacBooks as well. I'm going too fast. Sorry. You want to go? Yeah, go for it. Suspense.
네, 상의도 하나 남았습니다. 네, 저희 드림 플러스 상으로 저희 맥북 준비했고요. 네, 네 받을 팀은 제임스 웹3 팀입니다. 대학생들로 되어 있는 팀인데 2박 3일 동안 진짜 열정적인 모습을 보여줘서 수상하게 되었습니다. 축하드립니다.
right. Back to what I was saying. All right, so what I was trying to say, this is the prize what we would consider all of the judges we talked about, like what we think is like, you know, the best winner, so to speak. The categories or the criteria that we sort of evaluated were important to consider. So of course there was a lot of technical challenging work that's been done here, but there's also this aspect of business relevance. How does it benefit the Cosmos ecosystem? How does it benefit interoperability at large? How does it sort of benefit the narrative that we're trying to push forward? Also novelty and the cool factor are very important. So with that being said, we had sort of negotiated, what are we going to do? Who's going to be the first person? Who's going to be the team that's going to be able to talk at Biddle? And I'm happy to announce that that's Team Orange Pulp. Give it up for Team Orange Pulp. I don't have anything to give you, but we can do another photo. We really feel that the approach that was really UX friendly, UX first, and I think this is a common problem in blockchain technology right now, where we're building a lot of cool technology, but it's not necessarily very focused on mass adoption. And I think their sort of UX friendly approach, US first, and very mainstream focused approach is very valuable, and there's a lot of potential there. So thank you so much. You did a great job. I think that was it, right? You have some final words, or was there more? Thanks.
Thanks. All right. Do you want to say some final words for the hashtag?
Yes, so I noticed that you all are taking loads of pictures, so if you're going to post it to Twitter, make sure to hashtag Cosmos Korea. We want to let the world know that Korea is a Cosmos hub. Yay. Congratulations, devs! You guys killed it! Woo! Thank yourselves for spending the last 3 days working on the Cosmos stack. Y'all are all cosmonauts.
Thank you. 네, 단체 사진 한번 찍을까요, 우리? Do you want to take a group photo all together? 다 같이 찍을까요? Let's take a group photo all together. 다 같이 나오셔서 한번 찍을까요? 아, 네네네. 네. 아, okay. Then we all sit down here. We're gonna take a photo like this way. So. Okay. Alright, alright. 사진 한번 찍고요. 그리고 꼭 트위터 올려주시고 텔레그램에도 올려주시고 저희 많이 또 내년에 같이 할 수 있도록 응원 많이 해주세요. 또 이런 또 경험을 또 내년에 또 하면 너무 좋으니까 잘 부탁드리겠습니다. 또 너무 축하드리고요. 또 다시 내년에 또 만나요. 감사합니다.
Judges or organizers, come on the stage just for photos. 네, 그냥 앉아주세요. 일반 참가자분들 잠깐 앉아주시고.